All right. Well, good morning, everybody, or at least for me anyway. From where all of you are, it's probably already lunchtime. So I think what we'll do is we'll follow the same schedule yesterday in terms of a longer break for lunch for you guys, and so we'll do that after we have Marcus Kett, who's going to talk about MicroStream. So. So without further ado, we'll admit people as they come in. So we'll get started, and I'll do a quick introduction, and then hand it over to Marcus Kett. Okay, there we go. Okay, so today is day 2 of Helidon SE, and thank everybody for whoever's here right now. Thank you for taking the time to spend some time on learning about Helidon SE. I think everybody who's here now saw all this yesterday, so we don't need to go through that. And basically the same thing as yesterday. We have the prerequisites, and what we'll learn today. This is basically what we'll learn for both days, talking about Helidon MicroProfile. And of course, MicroStream, I should have put at the end there, so I'll fix that. Well, I'll mention it here, right? So this was just a recap of what we did yesterday. We talked about Helidon MicroProfile, Jakarta EE, a little bit about reactive programming. I'll try to get a little bit more into that today when we talk about those two components, reactive messaging and reactive streams operators. We talked about Graal VM. We got started with Helidon SE to 3 different ways, using the quick starts on the command line, using the command line interface that's relatively new, and then very new is the new start project, project starter, which we experimented with all 3 of those. And then we converted a Helidon application to native code using Graal VM. We had a summary, and then I forgot to do the acknowledgements yesterday, so we'll make sure to do that at the end today. So the agenda for today, Marcus Kett is here to talk about MicroStream. We're going to go over these Helidon components, and again, a summary and the acknowledgements at the end. Just want to remind everybody too, who's here, that this is the first time we're doing this. We have a second set of training next week, mainly catered for the United States. So it starts at 12 noon Eastern, and so try to see any refinements from these sessions I can adapt for for next week and so on. The intent is to make this a very quality training session on Helidon SE, and then we can expand down the road and do more of these kinds of trainings. So all right, so MicroStream is well, let's see, there we go. So yeah, it's a Java native object persistence engine, right, for storing any complex Java graph. And it is ACID transaction safe, can handle changes, and we'll talk about ACID. As you can see right there, it's an acronym for atomicity, consistency, isolation, and durability. And there are things about correctness and consistency in ACID transactions. And here are the attributes for ACID. So an atomic transaction is indivisible and irreducible series of database operations, such that either all occurs or nothing occurs. The consistency refers to a requirement that any given database transaction must change affected data only in predefined or allowed ways. And isolation determines how transaction integrity is visible to other users. And then durability guarantees that transactions have committed will permanently survive. That's a little bit of that. There's so I know MongoDB is one of the NoSQL that actually follows the ACID principles. So with that, I'd like to introduce Marcus Kett. He's the CEO and co-founder of MicroStream, and he'll take it from here to discuss MicroStream and some Java Jakarta persistence.
Thank you, Michael, for the great introduction. And hello, everyone. And Michael, it's really a pleasure for me to be part of your training. So thanks for having me. So let me share my screen first. All right. So this is an introduction to MicroStream, which is now we call it micropersistence for microservices. And it's because we believe that microservices need a perfect tailored persistence that is really built for microservices. Because with microservices, many things are changing. So we have different kind of Java runtime, not using application server anymore, using lightweight runtimes like Helidon SE, using GraalVM native images. And we believe persistence is also a challenge with microservices. This is one reason, and the other reason is performance. And because MicroStream is based on pure Java concepts, and Java is ultra fast for data processing in memory. And I will show you performance demo first to see how fast Java data processing in memory can be. So here is an example application that runs also on our website. Here we have two applications running in parallel. It's a bookstore demo. So it's a common bookstore. We have 250 gigabyte data storage, and it uses a Oracle database. And we have one application that uses the standard stack. It's Hibernate and cache. And the other application uses MicroStream and pure Java. MicroStream only for storage, pure Java for data processing in memory. At the bottom here, you can see the query code that is executed. And here we can see that each query is executed with MicroStream, sometimes factor 12, sometimes factor 100 times faster, sometimes up to 1,000 times faster than a comparable JPA query. This is not magic or hocus pocus behind the scenes. This is really pure Java. You can see everything is executed with Streams API. So we search an object graph in memory with Streams API. And this is pure Java. We can do everything with Java Streams. So we have the perfect query language in Java. We have the perfect data structure in Java. We have an object graph. So with an object graph, you can use all Java types. You can use each data structure you like. You can use simple lists. You can use collections. You can use key value. Yeah, you can use everything that is supported by Java. And so we have actually a multi-model data structure in Java from the beginning. The only thing missing is how can we effectively persist an object graph, the changes in object graph, and how can we restore the object graph in memory without any expensive mappings and so on. And this is actually what MicroStream does. My name is Marcus Kett, so I'm CEO and co-founder of MicroStream. I am working with my team for almost 20 years on Java projects. 15 years ago, we started with building a Java development environment based on Java Swing. We built it Java Swing GUI builder and the database tooling. Then we migrated everything to Eclipse. So we started Rapid Eclipse open source project, which is also a visual Java development environment based on Eclipse. It's the entire framework is open source. And during this project, we worked on improving the JBoss Hibernate tools, and for almost 10 years now. And so this is the reason why we try to simplify and to accelerate database programming with Hibernate. But there are limits. So I will explain it later, where the limits are and where are the challenges. And this is the reason why we started the MicroStream project. Yeah, MicroStream is as Michael already mentioned, it's a persistence API. It's a wafer-thin Java persistence layer that runs within your JVM process. So within your application or in your microservice in the same JVM process. And it enables you to store any kind of object graph, any size and any complexity very easily, super simple. And vice versa, it allows you to load any Java object graph, mostly individual subgraphs dynamically, and restore the subgraphs in memory again at any time. And the difference between Hibernate, for instance, and MicroStream is that you don't have to deal with object copies. So MicroStream loads object references and merge the loaded subgraph directly into your object graph. So everything happens on your object graph. And so your object graph becomes an in-memory, a kind of in-memory database. And so everything is done on your Java object graph in memory, and you can search it. So we were not forced to create a new query language for that. So I've mentioned already, you can use Java streams for querying, searching, and filtering your object graph, and this happens in microseconds. And this is the reason why MicroStream is that fast, because the JVM Streams API is so incredible fast. Everything happens in microseconds, and so this is the reason why it's up to 1,000 times or even more faster than a JPA query ever can be. So you can download MicroStream via Maven, so it's very easy to include it into your project. The code is completely open sourced. It's available on GitHub, and we have database connectors. They are still closed source, but we will open source even the database connectors next week or so with the upcoming MicroStream release. Since last year, MicroStream is also integrated with Helidon MP and Helidon SE as well. And it's now also integrated with Micronaut, and we are working on the integration MicroStream with other microservice frameworks. As I mentioned already, so we started MicroStream project more than 10 years ago, actually. So it's not experimental. It's not just an idea. So it's already stable. It's production proof. So we used it in production for more than 8 years or so. And last year we open sourced MicroStream, and 1 month later it was integrated in with Helidon. And currently we work on MicroStream cluster that should be released in some weeks also. And we are working with other framework vendors to integrate MicroStream with microservice frameworks. MicroStream is the company behind the open source project. So we are currently 15 people working on MicroStream and deliver some value to the project. We are currently the main contributor to the project, and we provide large test coverage, provide updates, warranty, and enterprise support. We have a really fantastic advisory board with well-known Java geeks in the Java community. So we are very proud to have these people advising us. Okay, let's get started into the introduction. So the IT is changing all the time, and in the last years we saw really revolutionary changes. So the most important change, I would say, is cloud computing. And with cloud computing, we changed the way of running machines. So from physical servers to virtual servers that can scale in the cloud horizontally. So this was really dramatic change in IT infrastructure. Then from physical servers to virtual machines. And then from virtual machines to containers with Docker. And these revolutionary changes in IT go along with also with revolutionary changes in software development. And one of these changes are microservices, of course. And here we can see a picture of a monolithic application. So we have the business logic, the application logic, and we have modules in our application. And now these modules are separated into numbers of single isolated microservices running within their own container and running on a container platform. But there are some challenges with microservices, and this the problem is our Java stack that we have been using for almost 25 years for building monolithic applications. So we have the Java application server and we have the JVM, both built for monolithic applications running on big machines. And the challenges here are the memory consumption is too high and the startup time is too slow. And application servers are built to run multiple applications on one big machine. And now we should build a microservice with an application server. And this can be challenging. So actually, this is not really cool. So it's too heavy wide, memory consumption is too high, startup time is too slow. So that's really challenging for Java. This is the reason why we now have the micro runtimes. So all of these application server vendors, they created a lightweight kind like application server for running only one single isolated microservice as a container. And so we have these microservice frameworks. Then the other revolution, Michael mentioned it already, GraalVM. So the JVM is super fast because of our JIT compiler. After the JIT compiler is hot and is after the warm-up time, but the startup time is slow. And this is the reason why we need GraalVM. And the GraalVM project is very interesting. So it provides polyglot programming in native images, but I guess for most of you guys, polyglot programming is not that interesting. The interesting thing is creating native images with GraalVM. So we have, so Oracle says up to 50 times faster startup time and much lower memory consumption. So with the microservice frameworks and GraalVM, now we are able to create super fast microservices with Java. And so the architecture changes, and so the Java stack also changes with microservices. And now the question is, what's about persistence? So we use, we have JPA, we have relational databases. Both were a standard for Java for decades. So first we had the Java Enterprise JavaBeans, then Hibernate came up and was so successful and much easier to use. So it becomes the JPA standard. Now it's called the Jakarta Persistence API standard. But we believe both the relational databases and object relational mapping is too heavyweight, too expensive for cloud native applications. And this is the reason why we believe MicroStream can help you to simplify database programming and to build incredible fast services. And Java developers already think different in terms of database programming. So it's because we love object-oriented programming. We love type safety, elegant object models, clean code, pochos, standards. We love to test our code, test-driven development. And when we use database servers, then we live this way mostly in practice. So it's because database programming is not object-oriented. So we have, we see in query code, very often we see SQL strings. They are not object-oriented, they are not type-safe. Then elegant object models in terms of relational data structure. It's not because we are not able to use everything that Java allows. So we have to adapt our object model to the relational model. Clean code, I don't know. So pochos, we can't use pochos. So we have these annotations or interfaces to implement and so on. So and I think to use a relational database or a database server in the cloud is not really, in combination with a microservice, not really lightweight. It's the opposite. I believe it's very heavyweight. And this is the reason why in Java we anyway don't use all the features a database server provides. So in database servers, they provide their own data structure, relational database, of course, they provide relational data model. We can use, we also can implement business logic in a database server. So Oracle provides PLSQL. You can write stored procedures, stored functions, trigger, and so on. Java developers mostly avoid to do that. So most Java developers don't care for stored procedures or writing PLSQL code because we love object-oriented programming. So we prefer to write our business logic in Java, right? And also concurrency is solved by the database server, but in Java, mostly we also care for concurrency, user management, and also the query language. So of course, relational databases provide SQL, but so we have to, if we want to avoid SQL strings, then we need a Java API that is that wraps the query code to be object-oriented, to have a fluent API. So this is what we love, actually. And so this is the reason why we have this JPA layer that abstracts the database so that we can program against the JPA layer. So, and not getting in contact with the native database functionality anymore. So in terms of database programming, Java developers already leave the database native way. So we prefer the Java way, actually. This is important because with MicroStream, we go one step further, and don't use the rest of the database functionality. So we use with MicroStream even more functionality of Java. Microservices and traditional database servers. I mentioned already. I guess this is really challenging because there with microservices we have various rules, and one of these rules is each microservice that stores data should have its own database. So imagine you have hundreds of microservices. Sometimes you have thousands of microservices, and each microservice should have its own database. This can be challenging and very expensive with database servers in the cloud. Furthermore, we have other challenges in database programming in general. So this is, by the way, not, don't get me right. So, sorry, please get me right. I don't want to bash relational databases and JP programming. You know, I have spent more than 10 years with my team improving the JBoss Hibernate tools and improving Hibernate programming with Java. But the core problem can't be solved with object relation mapping tools. And the core problem is that the systems are different. In Java, we have objects, we have object graphs. With databases, they have completely different data structure. The relational database uses relational data model, and both are not compatible. In other words, they are actually completely incompatible. Why? It's because here we have various impedance mismatches. Granularity mismatch, for instance, so the object model is much more, or can be much more granular in comparison to a relational model. So with the relational model, you have only the tables and rows. Subtypes can't be used in a relational model, and so on. So with the Java object graph, you can easily go through an object graph from one node to the other node. So it's super easy, only calling some get methods. This is not possible with the relational model. So here we need SQL and so on. So, and we have to, and object relational mapping frameworks have to combine both worlds, and there is always a trade-off. And here in Wikipedia, we have an article that explains impedance mismatch, and the core problem is that the systems are incompatible, and this is the reason why the system gets more and more complex, and object relation mapping is only a way around the problem, but it cannot solve the core problem of different systems. You can also choose a NoSQL database for persisting your data with microservices, of course. And we have various very successful new NoSQL database approaches, vendors like, yeah, Michael, you mentioned already MongoDB, Neo4j, for instance, if you like graphs. And actually, as Java developers, we should love graphs because we have the object graph. So you can use a NoSQL database as an alternative to the relational model. And the question is this the better approach? I would say it's an alternative, but actually from it does not solve the core problem, because all NoSQL databases come with their own database-specific data structure or format. And all of these data structure and formats are also incompatible with Java object graphs. So with NoSQL databases, they introduced key value or document. So you have to convert your objects into JSON mostly, or XML format. I mentioned Neo4j. Neo4j is a graph database, but the Neo4j graph model is not compatible with the Java object graph model. So they have their own database-specific graph data model. So no matter which database you use on the market, they are all incompatible with native Java object graphs. So we have actually the same problem here as well. So anyway, we have to use object relational mapping or other mappings or data conversion through every single read and write. And this can be a problem, because it increases the complexity of our system. It increases the complexity of writing queries, testing, and it's a latency. Yeah, through every single read and write, we have a latency. And this means so the performance goes down. And if you want to have the better performance, then we need bigger machines. So your costs will increase, or we need another layer in our system. How can we accelerate queries and writes? Actually, queries, so reading access with memory, in-memory computing. Yeah, why is in-memory computing cool? It's because of access to memory is incredible faster than access to a hard disk, for instance. So we talk about when we talk about query time, database query time, then we talk about milliseconds. So each query is executed in milliseconds. When we have access to memory, then we talk about nanoseconds or at least microseconds. And this is the reason why access to memory is incredible faster, sometimes up to 100,000 times faster than access to a hard disk. So how can we use in-memory computing? So yeah, we can use here additional layer. So we can use a caching layer. So this is the reason why in traditional JPA architecture, we have Hibernate, and we have an additional local cache. For instance, cache as a Hibernate second level cache. That's great. So now we can store our result sets in a cache, in a local cache, and then it's much faster to read the results from the cache, of course. But the system complexity increases because now we have additional caching layers, so we have to configure the cache. We have to care for how we can update the cache or defining timeouts and so on. So it increases more and more. And so if you believe that your reads are now executed in microseconds because you only read the object from the cache, then you're not right. So because the objects are mostly deserialized by reading the object from the cache, and it also takes milliseconds. So even if you have access directly to a local cache, it's not that fast as we expect. So we have no microsecond access time with using object relational mapping. Then another strategy is, okay, then let's use in-memory data grid, or let's use a distributed cache. Perhaps this can be faster because it's called a distributed in-memory cache. It's in memory. It seems that's incredibly fast, but keep in mind the cache, the distributed cache, is runs not within your application. So you have through every single read and write, you have a network call. So, and this is not really in-memory performance. And this is the reason why, if you have access to a distributed cache, it's not executed in microseconds. So it depends on your network. And this is conventional architecture, distributed application using a relational database server or NoSQL database server, using in-memory data grid, or using distributed cache. So very complex architecture. And in many projects, we see additional search cluster. So many clusters to run a database application or running microservices, very complex architecture. So, and we were thinking about, could this be faster? Could this be easier? And yes, it's possible, because more than 10 years ago, there was a pattern created, or it's called system prevalence. It's from, this article is from Professor Dr. Johnson. And system prevalence is a pattern that says this is the fastest and simplest way to provide ACID persistence for Java objects. So you keep the system state in memory, and everything, so complete database operations, data processing is executed in memory with pure Java, for instance, streams. And the only thing is you need persistence, and to get persistence, the simplest way is to create a snapshot of your system state. So this is super simple, super easy, and it's fast, and your architecture keeps clear, simple, easy to implement. And I met many Java developers. They tried this concept and used this concept in practice. But in practice, there are also challenges. So you can see, if we need persistence for our system state, then we have to create a snapshot of the entire system state. This is easy on one hand, but it's also challenging on the other hand. It's easy because now there are no more mappings, there are no more database-specific data structure, there are no more formats, no latencies, because of data conversion behind the scenes, like JSON conversion or so. But there are many other challenges. So because if the system state is big, so if you have gigabytes of data in your memory, then it takes too long to create a snapshot and to store a snapshot. Between the snapshots, you can lose data, of course. Then the database size is limited to your RAM size. And if you restart the application, then you have to reload the entire system state, which means the entire database. And this sometimes can take minutes, sometimes this can take hours. And this concept is not really working with microservices. Okay, but with MicroStream, we do pretty much the same. But the difference now is with MicroStream, we don't store the entire system state. With MicroStream, we only create snapshots of the changes. So we only persist the delta. And we are able to reload single subgraphs. And this makes the difference. And with MicroStream, we have solved all of these problems and use only and can benefit from the advantages of system prevalence. So this is the explanation of MicroStream again. How does it work? With MicroStream, we have really a thin persistence layer that can replace Hibernate or custom mappings. We have our business logic. Doesn't matter if this monolithic application or a microservice, but it's built for microservices. We have our system state in memory, which means our Java objects. And here you can use any kind of object graph. You can use any Java types. You can use any complexity of your object graph. You can have really thousands or millions of nodes in your object graph. Any complexity, you can use circular references, use and build everything that is possible with Java. Then you add MicroStream, and you, of course, it runs with a JVM or native image. And with MicroStream of microservices, of course, you will mostly use native images. Then we need a persistence where we store the persistent data only. And here we can use almost everything, every storage technology. So it can be plain files. We can use even a relational database to store the data. It's because MicroStream creates binaries. So we can also use a relational database to store our binaries. And we can use any NoSQL database to store the binaries. And it's because, yeah, we have optimized binary format. And the obvious way in the cloud, and the most, and the cheapest way is, of course, using plain files to use persistent volumes. So there, in comparison to database services, no costs or not dramatic costs. Or you can use, which is recommended, you can use blob stores. So they are built for storing binaries. Like in the Oracle Cloud, we have an Oracle object store. In AWS, we have AWS S3. So this is predestinated to use and to store the binary data that are created by MicroStream. So with MicroStream, you only have your Java classes. That's it. No more database-specific data structure. We have your object graph. We persist the object graph. There are no more mappings, no more data conversion. So we eliminate all these latencies between the app and or the service and the storage. It's a simple architecture. It saves it because you eliminate all these latencies. We save lots of CPU power. We save energy and cost, of course, of infrastructure. And now we are able to query and search directly on the object graph with Streams API. And here we talk about microsecond response time. So even if you search really huge object graph in memory, gigabytes of data, thousands of nodes, this will be executed in microseconds with Streams. And so we have these incredible numbers on our performance demo. We provide, as I mentioned, database connectors. You can also store your objects in Kafka. You can also store your persistent data in Hazelcast as a storage layer. But it's recommended to use a blob store or plain files. This is the cheapest way. Then it runs, MicroStream runs, it's a Java API, so it runs wherever Java runs, on desktops, in the cloud, in containers, even with GRAL VM native images. And we also have an implementation for Android. So if you want to build mobile applications with Android that are connected work together with a Java server, with the Java backend, then you can use one and the same persistence layer for both platforms. The only requirement is Java version 8. And you can, of course, you can use MicroStream with all JVM languages. MicroStream is not only a persistence. The core of MicroStream is a serialization. So we persist the data by using serialization, but this is not Java serialization. And there are numbers of reasons why we don't use Java serialization. It's insecure. It's not fast. It's known as to be very slow in comparison. And with Java serialization, it's not possible to merge the loaded object directly in the object graph. So there are many reasons. So this is the reason why we created a fundamentally new serialization from scratch. That's, by the way, solves the biggest security issue of Java serialization, which is deserialization attacks. So with MicroStream, it's not possible to inject malicious code and execute malicious code through deserialization, by the way. So if you want to, if you need high secure serialization for data, for transferring your data, then MicroStream can be a solution for you. On top of the serialization, we have the persistence layer for the JVM. I mentioned it already. Persistence layer for Android. Then we added some important features that are not defined with the system prevalence pattern. For instance, what happens if my classes change? So we have this legacy, so-called legacy type mapping that cares for class evolution. We have a file system garbage collector because MicroStream stores the binaries appended to your file storage. Will go into the detail later. We store, each store is stored appended to the file storage. So we have older versions of objects in the storage which can be removed, so you can keep it. So it's your decision. You can keep older versions of your objects in the storage, which means your storage will grow more and more. If you don't want to grow your storage more and more, then you can use this file system garbage collector that removes older versions, older object versions from your file storage. We have this file system abstraction, so you can define where your storage is located, can be everywhere. We have these database connectors. We have a REST interface that allows you access to the storage data by using REST. And on top of the REST interface, we have a graphical user interface that allows you to browse through your storage data. We have native backup functions. If you use a database system to persist your data, then the database system provides a backup functionality, of course. If you use plain files, then you can use the MicroStream backup function. We have converters to CSV and working on JSON converter and other serialized framework like protocol buffers. And currently we work on microstream cluster that will be introduced in 4 weeks. And all of this is provided by microstream. Okay, let's have a look on the code. That's really simple. So here we have one customer class, and here we can see actually nothing specific. It's a POJO. Most important here is there are no annotations. You don't have to implement interfaces like serializable. With microstream, you can serialize, which means store any Java type that is useful, that is suited to be stored. So you can store a thread, of course. So everything that can be restored in memory can be persisted by microstream. There are no superclasses, no interfaces, no annotations. So really plain Java objects. That's super easy, which means if you want to persist data from your objects from your dependencies, you can persist it with microstream. The object model is a pure Java object graph, a native Java object graph. Yeah, you can use all Java types, collections. Yeah, you can also use subtypes if you like. You can use circular references, and microstream will be able to persist everything. It depends on you how you build your object model. So yeah, if you search an object graph with streams, it's important that so that the structure of your object graph, of course, is important, but this is not a microstream thing. So it's only object modeling. So nothing microstream specific, and then you use microstream to persist your objects. To persist an object, you just have to call one store method. That's it. So you have to create a microstream instance, and the microstream instance creates the storage. And then you can store your objects with calling one store method. And the only thing is you have to call the store method at the owner of the object. So which means if you have a collection and you want to store one object in this collection, then you don't store the object, you have to store the collection. And microstream stores only the delta, only the changed objects will be persisted. That's it, super easy. And each store is an atomic operation, which means it's an all or nothing operation. It's transaction safe. It will be stored. So microstream creates a binary data and stores this binary appended to the file storage. If the store fails, then there is no rollback. So it's not mandatory because there is nothing happens. If the store fails, then no object, no binary will be added to your file storage, or a destroyed object, destroyed binary will be stored, and this will be removed by the microstream garbage collector. So in comparison to a relational database where you override rows or data in your row, microstream never overrides data. It always stores data appended to a file storage. So which means if you call a store method 100 times, then you will store the binary 100 times appended to your file storage. This is not a problem because of the garbage collector. Then to load objects, you can define your references, your object references as lazy. If you don't define your object references as lazy, then it's automatically eager, and MicroStream will load the object initially into the memory through your application start or your service start. If you define your object references as lazy, then MicroStream does not load anything into the memory. As soon as you call a get method, then MicroStream loads the object reference into the memory and merges directly into the object graph and updates your object graph. So it's a fully object-oriented concept. There are no more classic selects, just called get methods. If your object is already in memory, then you get the object from the JVM. If the object is not in the memory, then MicroStream loads the object and you get it. All I/O operations are multi-threaded, and you can use shells. So which means you can parallel your I/O operations. The more cores your infrastructure has, the more channels can be used and the faster I/O operations can be executed. The I/O operations in general are very fast because there is no more data conversion, no more mapping. So it's almost the performance of your hardware. Writes or reads are executed as fast as your hard disk is. All right. So I have a small animation here. So here we can see our architecture, the app logic or service logic. The memory is empty. So when we start a microservice initially, then we need an entry point. This is the first node of your object graph. It's a MicroStream instance. And the MicroStream instance is combined to a file storage. Can be everything. Can be plain file. Can be a blob store. Can be a database where we store the binaries. Anything. So and now adding and storing objects, that's simple. So we add some objects here. And when we call the store method, then a binary is appended to the file storage. So then we add some more objects, create objects, and add it to the object graph. Then we call again store method, then another binary is stored, and so on. So this is really simple concept. So your object graph in memory gets more and more complex, and we store binaries to the file storage. If you change objects, that's pretty much the same because there is no difference between a new object instance or a changed object. So if we change here some objects in the object graph, then we call the store method again. And then again, there is a new blob stored, new binary stored to the file storage. When we start the service, the microservice, and there is already data in the file storage, then MicroStream loads all informations about the data structure into the memory initially, but only the object IDs. So if you have hundreds of gigabyte storage data, then MicroStream loads only the object IDs of your entire object graph into memory and creates the object graph. That's really fast because we don't load any data. So only if you don't define your object references as lazy, then MicroStream loads the data also. But if you define all your object references as lazy, then MicroStream don't load any data, only object IDs. Okay, then we can load when we call the get methods, then MicroStream loads the data into the memory and merge your objects into the object graph. This is lazy loading. Here's the code again. So this is really simple concept, completely object oriented, and so we can load all these object references into the memory by calling get methods. The memory is managed by the garbage collector of the JVM, but you have full control of your lazy references, which means I load more and more object references into the memory. So now I'm afraid of out of memory errors. Then I can clear any lazy reference anytime, and then it will be removed from the memory. And yeah, if you remove an object from the object graph, then the garbage collector removes the object, the garbage collector of the JVM, and then you store the object graph again, then it's also deleted from the file storage. So memory management is also very simple. To query object graph, you can use Streams API, GraphQL also, and this allows you to search your object graph super fast, and you will have microsecond response time for all of your operations.
Marcus, I had a question.
Sure.
Can we use this on raw JSON files? Because we don't use a persistent. So in our architecture, we do not use a persistent store. So most of the cases, we just write data to raw JSONs on flat files. Will MicroStream work with raw data JSON files, like normal text JSON files?
I'm sorry, can you please repeat it? It's super hard for me to understand this.
Okay. Can we work with raw JSON files using MicroStream?
Yeah. You use, yeah, you can use JSON files, and you can store the JSON files as if you like. So then, yeah, it's because you can persist almost everything that can be used by Java. So you can use Java collections, you can use also documents to store it, and you can store also your JSON files. So this is possible. Is this the answer of your question?
Yeah, I thought some sort of data store or some sort of might be needed, but if we can read and write directly to raw JSON files, I'm okay.
The connection is like, I'm sorry, the connection is really bad here. So you use pure JSON files for which purpose? So is there a specific purpose, or do you just want to store some JSON files like images?
No.
Or is there?
So we persist all our data on a flat JSON file.
Okay.
Right. So my question was, can we directly read and write to raw JSON files? We do not have a persistent store or a database store. It's just like a raw file to which we do all the read and write. So
yeah, sure. Yeah, you can do that. But I think there is no advantage from MicroStream. So yeah, if you convert your objects into JSON, then you can store and load it with MicroStream, but you have the JSON conversion. then there's no advantage from MicroStream, but you can do that, of course.
Cool. That answers my question.
Okay. Actually, we use MicroStream. That's really funny. To avoid this, we have some use cases. For instance, when we store objects into Kafka and read it from Kafka, or if you have serverless functions like AWS Lambda, where we have to persist the system state and to restore the system state when the Lambda is awakes again, then also JSON conversion is used currently. And with MicroStream, actually, we replace this JSON conversion to be more object-oriented and to avoid the JSON conversion, to be able to store any Java objects, to store any complex object graphs with circular references, for instance, which is not possible with JSON. So in many cases, the idea is actually to replace JSON conversion with MicroStream serialization. But of course, if you want to do it and if you want to store JSON, you can do this with MicroStream. Garbage collection. So here we have if objects change in the object graph because of a new version of your class, then and you store this object again, then we have different versions of objects in the file storage, and this is solved by our garbage collector. So and the version conflicts are solved by MicroStream automatically. For this purpose, we have so-called legacy type mapping. The functional principle is really simple. I'm just look if I have some graphics here. So I played around with some new graphics for MicroStream. It's because I never do a presentation as a copy. I always try to improve my presentation, so which means is but I'm sorry, I cannot find the new graphic. If MicroStream loads an object from a file storage and MicroStream recognizes, oh, there were class changes. So for instance, you add a new field, you change the type of a field, like there was integer and you change it to a string, for instance, then MicroStream recognizes automatically there are changes and it can be solved automatically. So the simple cases can be solved automatically. Simple cases are you have new fields, you have fields, you have removed fields, and you have changed types. This can be solved by MicroStream automatically. If you have more complex cases, like you have defined new objects or you changed objects, then you can define a so-called legacy type mapping. Then MicroStream loads the old version into the memory from the file storage. It recognizes the class has changed. Then it maps it through runtime in the memory. Then you have to store this object again, and then the new version of your object is stored persistently. And then you have different versions of objects in your file storage. Here we have the red ones are legacy. Yeah, you can keep this. So you can decide if you want to keep this different versions of objects in your file storage, or for any case, or you want to remove it. Then you can use the garbage collector. So just have to define some rules for the garbage collector, and the garbage collector, the MicroStream garbage collector, removes the legacy objects behind the scenes automatically and cleans up your storage. That's the functional principle. I mentioned the channels already. So if you use channels, then you can parallel your I/O operations. The MicroStream creates multiple storage targets. Everything is multi-threaded. The more cores you have, the faster your I/O operations will be executed. And then there are some rules, of course, and some differences in terms of the philosophy and the database paradigm. It's a kind of paradigm shift in database programming. This is important to mention, and this is the most important difference to traditional database servers. So here on the left, we see the traditional database server paradigm. We have our application instance, and we have a remote database server. At the remote database server, there is your database located, and the persisted data are located in the database server. So everything is together in the database server. And the queries are executed on this remote database server machine. That's the traditional database server paradigm. It's the same with relational databases and NoSQL databases. With MicroStream, this is completely different. With MicroStream, you have a storage target, and there is no difference if this is only a hard disk where you store your persistent data in plain files, or you use a blob storage, or you use a database like a relational or NoSQL database. There are only the persistent data, and we use it only to store the persistent data. The database actually is located in memory, in the same JVM process as your app or microservice. This is the paradigm shift. So this is now the single source of truth. Your object graph is your in-memory database. If you change data in your object graph, then you change the database. It's very important. Now you can say, oh, the database cares for concurrency and locking and something like that. That's true. But in modern database applications, we have to care for locking anyway. So most developers don't use pessimistic locking anymore. They mostly use optimistic locking, which has to be implemented in Java anyway. So you have to care for locking, and you have to care for concurrency. And for that, you can use all Java concepts. So we provide no concept for that, because MicroStream should not be a database system and should not be another database server. MicroStream is only a persistence library to store and load your object graph. That's it. Separation of concern. So we don't want to be the next database server. There is, and this is the reason why there is no query language. So this is can be Streams API is perfect for that use case. So these are the conceptual differences between database servers and MicroStream. We talked about lazy loading, but most question, one of the most asked questions is, what's if my storage size is too big and I have a small microservice that runs on a micro machine? So most microservices need a super tiny container, or if you can also use serverless functions like AWS Lambda to run your microservice, then you have mostly micro machine, which means half of a CPU or and only 250 megabyte of RAM, but you have terabyte storage size. Oh, then are we now in trouble because we have to load the data into the memory? It's possible. So if you have enough memory, then the recommendation is, of course, yeah, load your data into the memory. Then everything will be executed in microseconds. There are no more latency anymore. So this is the fastest system you can build. But keep in mind, if you create microservices, then microservice should have a fast startup time. Then perhaps this is not a perfect use case to load all your data into the memory. It depends on your use case. If you build a monolithic application, you start the app once and the app runs for a year or even longer without shutting down the system, yeah, you can load all the data into memory, of course. And by the way, memory is expensive. Yes, that's true. But it's more expensive to build a distributed system that uses a distributed cache cluster, a searching cluster, and so on. So it's more it's much cheaper to buy some big memory machines. But if you don't want to run these big memory machines, then of course you can run smaller machines, micro machines with only some gigabyte or megabyte of memory. Then you have to use lazy loading. With lazy loading, you can define which data are loaded initially into the memory when the system starts, and which data are loaded on demand only. If you use lazy loading for everything, MicroStream does not load any data into the memory, then you can have a terabyte of storage size, only 500 megabyte of memory, then you're good to go. It's fine. You can do both concepts. It depends on your use case. Then we have some architecture rules. These rules are very important. So MicroStream is built to be a persistence for a single Java machine. It's for a single Java process, which means you have one MicroStream instance, one storage node, one JVM process. That's perfect. If you have a MicroStream instance that stores data into various storage targets, that's not a problem. So you can do that. You can store one and the same object into S3 or in a plain file at the same time. That's not a problem. If you want to run multiple instances of your service or your application that store data into one and the same storage target, then this is a problem with MicroStream as it is today. Then you have to use MicroStream cluster. MicroStream cluster enables you to run multiple MicroStream machines, and MicroStream cluster will replicate the object graph in memory and allows you to create a distributed Java object graph that can be shared through hundreds of JVM processes. Then you can scale your microservices dynamically. You can scale it up, you can scale it down depending on the workload of your system. With the MicroStream cluster, you get object graph replication. It's really simple to implement. You can scale it simply. You can define the scale out and the scale down. The single instances of your service will be super fast because you keep the data in memory. You have a real-time response time. You can really handle huge workloads. And with MicroStream Cloud, we will provide a full managed MicroStream cluster. But this is work in progress. Memory management, I've mentioned already, so don't have to care for that. It's managed by the JVM. You have full control of your lazy references. So, and if you want to run big memory machines, so at AWS, and I guess also in Oracle Cloud, you can run even terabytes of memory size machines. And you have concerns about garbage collector pauses, then yeah, you can check out alternative JVMs like OpenJ9 or Azul JVM that are built to work with to run huge memory sizes. And if anything is missing in MicroStream, of course you can open an issue, but you can also have a look on the Java ecosystem that really provides everything, almost everything we need for super fast data processing in memory. You can use GraphQL if you want to. If you need a full text search, you can use Apache Lucene. So we have really a great ecosystem that is so powerful that allows you to build really the fastest application with pure Java. All right, so this was a short introduction into MicroStream. In addition to that intro, we provide MicroStream training, and you can now book this MicroStream training for a special price. It's $0. We provide ticket codes for all of our participants of this Helidon training, so you can also enroll for this MicroStream training for free. These trainings are sponsored by our partners, JavaPro. MicroStream sponsors the trainings, and it's supported by the Helidon team at Oracle. So check out, you can book any MicroStream course for free. So pick out the date that fits best for you, book the training. You can invite your friends, colleagues, and so on, yeah, to learn how to get started coding with MicroStream. So then in this MicroStream training, we are focused on coding with MicroStream. And after this 2 days training, you will know almost really everything about MicroStream because it's so simple to implement. And there are only a few rules, and the most rules or concepts are actually Java concepts. All right. Are there any questions about MicroStream left? If not, so you can. Right. If there are no more questions, then yeah, thank you very much for joining. Thanks for having me, and you can find me on Twitter or send me an email or contact Michael. Thank you.
Well, Marcus, thank you for that comprehensive introduction. You know, to MicroStream. It is on my to-do list to actually take the formal training. So you know, I have many plans for once I retire from my day job, but so, but in any event, yes, I will definitely you know, get to do that, especially since, you know, we're working together quite a bit. I think that's a good thing. So welcome back. And so part two of this, of our agenda today. We'll talk about all the different, well, it's not, it's not the full suite of components in Helidon. There are components in Helidon SE, components in Helidon MP for MicroProfile. But what I thought I'd do was cover the ones that would be more than likely used in your applications. There's others we can take a look at the full list. I can show a document that will do that. Yeah. You don't mind hanging out real quick on that. Should have put this in a I should have put this in a slide, but I didn't. Okay, so here we go. So there's a full list of components of for Helidon SE. You can see a lot of them that we're going to be covered. So today, but there's ones we aren't like WebSocket or gRPC or some of those, but and then cores. And then Helidon MP, very similar. You'll see some other ones like long-running actions, fault tolerance, JAX-RS, which is using the Jersey implementation, JPA, and all that good stuff. So, but yeah, this is the full list. All right. So, all right, we did that already. Okay, thanks again, Marcus, for taking the time today to do a comprehensive introduction to MicroStream. So these are the components, as I mentioned before, that we'll cover. We'll start them in order. So we'll start with web server. It is an original Helidon component, and it is inspired by Node.js and other Java frameworks, but it runs on top of Netty, which is a reactive and asynchronous server already. So as I would imagine that it's a downstream distribution of that. There's a web server interface that provides that basic server lifecycle, and you would provide configuration, routing, error handling, and all these other things, right? Designed to be reactive, and there's a start method that returns an instance of the completion stage template right there with that takes a web server, and to start the web server, and then you can use the toCompletable future method to stop the server itself. So for all of these, I thought I'd put in the Maven and Gradle coordinates, just so so you can get an idea what that is. 3.01 is the current version. I took the time to refresh my Helidon, my Helidon fork, for any potential contributions to open source. And there was a bunch of examples which I thought I might use today, maybe a couple of exceptions. So I was going through them, and one of the things I found in the examples was a 3.0.2- snapshot, but my IntelliJ IDEA didn't like it, and so I would change the POM file to 3.0.1, and everything seemed to work. So, but anyway, yeah. So that is that. Now the create method is overloaded, and there are a number of ways you can, create your server. The routing method is more popular, and also the config as well, routing and the config, that third create method right there. The last two I have not experimented with, so you know, I'm not quite sure exactly how that would work, but I'd have to try that out in order to get a better idea. So here's a generic way of starting a web server. Since it is an interface, you know, it's a builder method, and then you can, you know, you bind your address and then a port and then build it. But there are just so many other ways you can do that. It's just a very simple way. And then for configuration, we saw a lot of this yesterday in a YAML file. You know, you can define your server port and the binding address, and you can create a web server this way by creating an instance of config, and then, you know, using the same way except using a create method. And then there's an assumed instance of routing, and then you know, pass in the config.get and then get server. All right, so we have a demo, and as I mentioned, I decided to do in case you're interested. So this is my fork of the Helidon, the entire application itself, and then, you know, this is a way to get started with doing open source contributions. You create a fork of the original, and then you clone yours, and then create that triangle, you know, to then make changes, do the pull request, and the whole 9 yards. I'm sure a lot of you have done this already. So, so yeah, it contains, you know, this is the main folder right here, and so you see these are all I think the implementations of the application, but in particular, what we're going to focus on today is the examples folder, which is here. Okay. All right. So you can see all the various things. So we thought we'd start with that. Oh, there's config right there. I didn't do that one yet, so we can do that one real quick. There's an employee app. We can play with that too. I have my instance of Mongo daemon running, so we can do some database stuff as well. So, so there's a lot of things we can experiment with today. So I've already taken the time to bring in various, let's see, you know, various examples, you know, individually. So this is the test. And, you know, as I mentioned earlier, I had to, you know, change. Where is it? Oh yeah, right here. So this said 3.0.2 snapshot. So, you know, I guess the folks at Helidon have their own local that they can use. So, and that's fine. So, but anyway, yeah. So a lot of things you can do. There was a test here. I forget if that. I mean, we saw a lot of these yesterday, right? You know, so so in this example here, this is the. Well, let's say start with the main first. It's always the best way to go. All right. All right, so here's some routing, right? You would use the, you know, the routing interface or class. Forget which it is, so it's imported here, right there. So, and it's probably an interface because you have a builder there, right? And then you can define endpoints. So get endpoint, post endpoint. And then build, and then call the start server method with just routing. So this will be the, it'll most likely do the start server routing. There's also a media context being built in there. This does another instance. Ah, there it is. So it's this one. Oh wait, I take that back. All right, so there's a number of different ways here. This is routing as a filter. So you can see a number of other ways to use this. All right. Now, if I tried the, when I tried the example, oh, that is all that. Okay, good. That is the web server right here. Yes, right. And I did MVN test and things blew up, and which is I hate that when that happens. So I'm pretty sure of that. So running the tests. Yeah, so there was a bunch of stuff here I think that needs to be fixed, and then who knows what. I believe, running JDK 17. This is from version 3, of course. Yep, I'm running 17 here. So, so I'm not quite sure. Oh, there is something here though, right? There is a name, but oh, interesting. It does say 0 failures. Okay, well, let's take a look at that real quick. Maybe have this open. Yeah. Okay. There's the endpoint. Yeah, I don't know what exactly the issue is here, but we can always look at one of the other examples, and I mean, you see these yesterday, but this is just another way of studying to do a number of things. This is a way of handling parameters and headers. All right, original code or organized code. I'm sorry. Read content entities. So there's a lot here, really. So. So I'm not sure why that was running, but if you do the, okay, so we got to look at the README. Right? One of the things that was kind of disappointing is when you package and run this, so it says that you can do that, right? And then when you do change that, something just fine. So you see a lot of these correspond to the methods that you just saw. All right. Now it says the web server is up, and then it dynamically identifies a port. And it doesn't do much. So kind of disappointing. But we saw a lot of that yesterday. But I wanted to try something else just for grins. It did say java.jar example basics.jar, but I don't think that exists. Target. No, unless it's elsewhere. I don't know. But let's just try it anyway. You never know, right? Example. Oh, I see. This example basics. Probably doesn't exist. Nope, I just found that one. So okay, I don't know why that's there like that, but well, we're going to see more instances of this. This is just kind of very kind of a complex way of doing this. We could look at some of these here. Here's an update method where you can do various things. So I'm not sure why this isn't working as advertised. It has all this stuff that it defines. There's a name class. So, so if you're interested in learning more on this, like I said, we'll go back and look at some of the other web server basics on this. So But yeah, we'll continue on that. I don't know exactly why it is what it is, but. All right, so web client is our second one. As I mentioned yesterday, this was introduced later in version 2.0, all right, and it handles responses, to HTTP requests. Again, it's reactive, all right. So it's asynchronous. So as it says there, allows you to execute requests and handle responses without having to wait for the server. And then client requests only the amount of data that it can handle at that time. So, and the benefit of that, there's no overflow of memory. So, just like web server uses a builder pattern. Okay. There is the Maven and Gradle coordinates for that. And you'll notice it's pretty standard pattern you'll see throughout these. So I just wanted to put them there for completeness. And there's using the builder pattern right there. Base URI get, same thing with the host and .build, just one of the easier ways to do that. And oops. So now we go to let's see, it's client. Okay. This was standalone, that's right. All right, this one was a little bit more useful. Okay. All right. So again, this one, this one kind of bases off the greet service. So, you see a lot of this, these reuse of the basic example from the quick starts. So there's a server main class here, and this is probably a little more useful right here. So we do have a get server port method. Okay, web server, start server. Here's config.create. Obviously going to be using an application YAML file, which has, and this kind of, I'm not quite sure, -1, I guess whatever's available -1, and that's kind of strange to me. I don't know if any of you have seen that. You can always change that, of course, right? So yeah, so it's getting so we do the builder, create routing. There's a create routing method that it calls inside there using the config being passed into it. So there it is. You go there. Even has some metrics on in this. And then, oh, here's the greet service where it instance of that. And so then here now we're going to create a routing, and then we're going to register the /greet endpoint, and we'll build that routing. Okay. And then we'll start the server as per normal. So, here's where how it's doing the reactive part. All right. There should be a shutdown somewhere. Yeah, it's not. But all right. So there's the start server. Client main. Okay. Okay, we're going to again start our config. So you'll see a lot of this as we go along today on all that. All right. So let's see, the URL has to be defined, and then config.get client. Okay, where was that? Oh, there it is. Okay. So that's defined here. Number of redirects maximum is 8. And then to be able to follow redirects, in a client. Okay. We're going to add media support for JSON, JSON-P that is in this case, and we'll build that. And we have a lot of methods that are being redirected to a number of others. So perform put method, perform get method, right? So you see all those that follow here. So using lambdas for that. So these are pretty, you know, for examples, these are pretty intense. And so the README suggested. Okay, let's do that. Oh yeah, and then the port number. Okay, right. All right. So we'll do that. So then clean compile. Oh, should have packaged it. So make sure it still works, right? Yeah, running the tests. Okay. And then it said to note, like, not run it yet. So Java IDE. Here's the port number. I thought I had it earlier when I tried this. It was working. It gave me a port number, unless it's over here something. All right. Web server is up. It didn't say that, did it? Oh, interesting. Web client standalone. Yeah. All right. Well, I don't know why that's not working. I apologize for that. It should be working. The joy of live demos here. All right. Sometimes it's better to learn things just from the tests, to be honest. All right. All right. Oh, there it is. Okay, so 57.515, but I don't know if that's not going to be running again. So, so now it says it's up. All right. So yeah, it's dynamically getting that, I guess, from.
Are you calling the dot await on the start method?
I'm sorry.
Generally, the web server does not start because there is a dot await that they call in tests.
Oh,
right?
there's a, okay. So something else running maybe, or?
Yeah, I mean, I used to get into this problem. If you go over the client main test code, they might be using a dot await call on the server start, right? So that is what completes the call to starting the server.
So interestingly, here's a port 57.515, but then there's a 57.518. And then we have other, you know, so if you look at the test file, all right, it should be before, we have an after, or after each. Okay, before each. All right. Oh, there's a test file paths to get text. I didn't see that before. All right, where's that hiding? There's another web config here right there, but where's the text? Huh. Test.text. Where is that guy heading? Yeah.
Paths.get. Is it generating it, or I don't know?
Web server. Yeah, it could be, but all right. So what's happening here? So we start. Oh, there's the await method that you mentioned, right?
Yeah.
Yeah.
As long as you don't call the await,
Right.
the call to the start server does not complete. That is important.
Yeah. Test file. There's that. But the test file equals paths.get. But you'd think that'd be around here somewhere, right? Let's see. Okay. I don't know. I don't see it at all. Yeah. Unless it's in test. Yeah. I don't even see it at all. That's weird. That's very strange. But
Are they creating it randomly somewhere in the test?
create a note. What I was thinking was to just, instead of going through all this, just define a port, explicitly define a port. But I'm still.
That's fine.
I'm sorry.
I think they are also deleting the file in the test. So
oh, are we? All right, let me see. Yeah.
If you go to the test,
Does it? Where was I? Was I in server? No.
No.
Oh no, I'm sorry. The test. I'm sorry. Yeah, there we are.
If you go to after each, they delete the file. So you will never find the file even if it exists.
Oh yeah. Okay, right. That's after each. So it's generating it, but then what's it putting in there? Let's see. No. All right. So before each, we do a test.text. Okay. And let's not worry. So after each test, then it blows it away. All right. That's easy enough. So we got to look for test file.
Can you go to the top of the test file? I think that is where the file is getting generated.
So let me see. Control F, test file. No, what is it? Text. Yeah, test file. Oh, did I spell it wrong?
Okay.
Okay, so there we go. Then we got 6 instances. Oh, test file download. All right, here we are. So, all right. So if exists, okay. Read string. Yeah. Oh, there's the hello world. If you run that, I think, yeah, that's on there. And that's it. Oh, it just asserts that it exists. It doesn't have anything in it, really. Okay. Test file download. All right. Very strange. So test file. Okay. All right, so it does that for, it shouldn't have to do that for all of them, but it does apparently. So if we look at the test output again, let's see. Oops. Let's see if I pipe it some more, see if it actually stops. Yeah, there we go. All right. All right, so the web server is up. All right, following request redirection. Okay, successfully for the message hello world. That's part of that test.text file. Web server's up again. So dynamically it assigns a port, right? That's interesting. Oh, so here's example metric get localhost server is up. Oh yeah, downloading server response to file. Okay. Yeah, there's a lot going on here too. All right. All right. These are pretty complex. We saw a lot more simpler examples yesterday, and I think maybe we'll go back to those and review those. But this is something that you can experiment on your own if you want to learn more. I got these from GitHub. So it's Oracle. Oracle / Helidon, and that's the whole thing. And you can clone the repo there and then get everything. So heavy stuff there. So all right, so config is next. This is another original Helidon component, from day one. All right. And just like microprofile config, right? It processes configuration data from various sources, puts them in a config object, and we already saw how to do that. And then there's a config interface. There is a couple other ways to define your own, or I guess define your own configuration name. That goes back. We can take a look. Well, let's take a look at the example here. I'd have to open that one up separately. So thank you. All right. So we got just go the basics. So yeah, a lot of these, just so you know, there are various various folders, various options. So I chose the ones that were more basic. So we'll go with that one again. CD basics. Okay. Oops. Takes a while to sync everything. All right. So you can already see here is the first thing you see when you load this is cannot find the artifact that has the 3.0.2 snapshot. So that's why you need to fix that every time. And I've seen that before in other projects. And then reload it. It's probably not on Maven Central or MVN repository. So, all right. So you only have a simple main here. Oh yeah, you can do the class path thing too. I had that on my slides, but there's ways to do that as well. And so here's our application.conf. All right. So this is JSON. I think one of you guys mentioned yesterday about JSON as configuration. So here it is. I've finally seen it here. So I kind of like this actually. So, but you can see where this would translate into a YAML file too. You can just use the colons and take out the curly braces and all these other good things. So we got a lot of stuff going on here with that. All right. So we'll keep that in mind as we go. There are no tests in this case. Okay. So config.get app.page.size. There was another config related thing, and I have to go find it. So app.page size. So let's there it is. Okay, so in this case, it's defined as 20. Okay. Oh, this is important too. I had a little configuration. I was trying that work yesterday, and you'd have to do. They have these as int, as string, and I'm sure some of the other types that are available. So if you want to get it, you have to get it that way. So it's kind of interesting. You do a regular get, right? The name of the configuration property, and then chain it with the as whatever data type, and then another get. So, but yeah, so oh, here's an as boolean, as list, so you have all these options available as well. All right. So we can run this, and I think this is pretty much the same standard. Yep, NVM package. Okay. Okay, so it just puts everything out there. So, and yeah. Close that. So this is just an example of how you can get those properties. But what I like about this one is the fact that you have a JSON file. I think, config provider. Let's while I'm thinking about it, I know I've done that elsewhere. Go back to my trusty. So one of these fine days, I'm going to update this website. It's it's going on 8 years. It has this particular. I do have a work in progress that looks much nicer. Yeah, I know I have an example of a config provider. We'd have to look at the documentation. I'm sure we can figure that out. So let's take a look. So we have, let's see, Helidon. Implementation version 3. Java docs. There we go. Big property, yeah, config, that's meta. I thought there was a regular one somewhere. Properties. Huh, that's weird. We have all these other different config things here. So let's see if we can go there and get all the, so config. Yeah, this gives you a lot of information on how to do the various ways of getting in from environment variables. And then there is a, there is an order of precedence. I don't know if I talk about it here. Where there's this 100, 200, and 300, I think. And so if you happen to have an environment variable, it will take that first, or, depending on what it is. So, so, well, here's a nice simple example, right? So, sort of should have shown to begin with. Yeah, I don't want to waste too much time finding this, but I can't believe I can't find that. Interesting. Helidon SE and then config. So this, this is, all the online documentation for Helidon, and they even have it in version 1, 2, and 3 when you first go in there. Hierarchical features. There we go. That could be that. Config node. Yeah, I remember something about that being. I mentioned this yesterday about a way to dig down into the configuration file by this dot notation. That's an example of that. Okay, well, property mapping, configuration. I wish I can find that. All right, so here's the system property, right? Environment variable, that kind of thing. And I could have sworn I had an example at one point. So here's, here's basically, various ways you can, use application.yaml, that application.properties. I don't know, maybe it's in the microprofile config in there. But there's a way you can actually determine whether you want to read from the environment, environment variable or a system property and those kinds of things right there. And I cannot seem to find it, and I apologize. I always think of these things, when the event is happening, right? That's Murphy's Law for you. Okay, so we saw that. Oh yeah, config sources right there. Class path. Okay, I should have. There's the Maven and Gradle coordinates. Okay, create methods. There's 2 of them right there. I know we talked about that, so I jumped the gun a little bit on starting that. So, all right, security is next, and that one's a little bit easier, a little bit nicer actually. Yeah, and I think I have the. So there's a number of options in this one, and a lot of this I think is going to assume you have various things all set in place. So I went with the basic auth with static content file, the attribute based one too. I think that's RABC or something like this. Yeah. But anyway, yeah. So I went with that one, basic. Okay. Yep, we already have the idea file. Yeah. So All right, so I have this open already, right? They have the roles. And there are also paths for, slash no role slash deny. All right, we'll see an example of that. There are some users defined. And it wasn't clear to me what the password was, unless it's defined somewhere that I didn't see. But the password is password, and you can see here that it says clear equals password. Okay. Obviously, you don't want to clear, I guess, for anything production. So for clear text. So you see Jack, Jill, and John. All right. We could have had some fun with that. We can, I don't know if the test might screw up, if I change things right now. So, but if we run this, everything's very slow this morning. I don't know why that is. We can take a look at the tests too once we're done. So everything passes. Okay. So okay, so we got all these endpoints over here. So this one here, I think should be the one that works correctly. I think there was an issue with this one too. Oh, it says you are. There was a way to log in. Okay, hold on. If we went like this. No. Five seven seven six seven. Yeah. Okay. I got a login page when I did one of these. So. So it works when I'm testing it, and then now all of a sudden it doesn't work, right? Classic. Try it again. Oh, you can number. All right, so maybe I'm doing something different here. Let's see. Oh, it zooms that one. All right, so let's see. Wonder why I had a different thing here. Let's try that one. No. Oh, it's terrible. Oh, maybe this. Let's try that. Honest to God, I had this working earlier. So. All right, there we go. That works. So it's still the same port number, but so I tried here. So let me try something that doesn't work. It didn't give an error message, but it just wouldn't let you in. And I type in Fred. It doesn't, it just starts again. So if you do Jack and then password, so then now you have, now you have everything here. So a lot of these endpoints that were defined are right here. So here's the public, and it says, you are, okay, right? So it gives you all the different, roles that you are and everything else. In this case, we're Jack, admin. Okay, so we're logged in as Jack. Okay. User role. All right. So now, in theory, if we do this again, I don't know if it's gonna. No way to log out, is there? So. All right. Oh, this endpoint's always denied. There's a deny endpoint that was okay. All right, so if we cut this one out. Oh, no, okay. There's no way to log. I guess it times out or something. All right, so let's take a look at this here. So, so we saw all the different ways, right? There's a builder main right here, right? So this is where, yeah, this is where you make that connection. And this is what I did in my, this is my security example from a couple of years ago. You do a map, identify that, and well, concrete is the hash map. And then you put from my user, which is probably defined in here somewhere, and then the name and the password, and then you provide a set of what role they may or may not be. All right, so you have user and admin for Jack, and Jill is just a user, and so on. So you can define those, right? Basic example, util start and handle print endpoints. That's this class right here. Okay, so just so it starts the server start method.get, and then puts a lot of output, and that's the stuff we saw in the in here, as a matter of fact. Yeah, that's all this stuff, I think. Okay. Yeah. All right. And then here's a lot of the routing here for that to register various things. So, you know, so for building web security, to register that. So then and anything with static and then a parameter is allowed for user. There's a web method in here somewhere, right there. Right, there's the index HTML. The same thing here, /user. So it defines all these, you know, all these endpoints and the security. So it ties all that together once you create your roles. Okay. And then, yep. Oh yeah, there's the wait. It says it's 10 seconds or 10 milliseconds, I guess it is. Oh no, seconds, time unit seconds. Okay. Yep. So you have all this, oh, secure user store, right? Build user store. And then here's the embedded class right here, nested class, my user. Okay. So, you know, it's not terrible to implement some kind of security in your, you know, Helidon applications. And you saw how you were able to build a UI to add somebody's name and all that. Let's see what else we have here. Basic example config.
Sorry. How about OIDC? OpenID.
Oh, that's a good question. Yeah. Where? Let's see. I don't know if it supports that. You have to take a look. See, that's a good question. Let's. Oh, there it is. I'm gonna get that out of the way. Do you guys see that little menu that comes up where it says stop share and everything else? Or no, is that just me for my benefit? Oh, all right. It's always in the way. That's the thing. All right. So yeah, so LS. Attribute-based Google login. I forget what IDCS is. Web server digest, often web server signatures.
I think Google login is kind of OpenID Connect.
Yeah, yeah, and I know So I'd have to see if there's any way you can use that, like, because like Okta, for example, you can, you know, create your
Oh,
own.
yeah.
Yeah, you can create your own forever free, you know, free account, and you have a defined number, you know, for that, and you create that. I have an Okta, but it's not using Helidon.
Auth0 is also as a provider.
Yes. What did I use? You know, this is, you know, I mean, if you don't mind, you know, poking around other things here. Let's see, I'm in my GitHub, aren't I? Yes. That's Helidon. Where's mine? I'll just go to mine. Repositories. I did some Okta stuff a couple of years ago. Okta Java CLI app. I think that was the only one. Using the Java SDK. You know, I have to take some time to get through all these potential security vulnerabilities, but you know, these are just examples too. So, yeah, this is from 3 years ago. So, so I was using JDK 11 and OpenJDK, and one of the things I started doing was, maybe I didn't do it here yet. All right, new user, new password false. Yeah, okay. Create client. Oh yeah, I was able to do security questions, you know. And this is dated because this is the old ACG and J Java users group, which is no longer, it's been rebranded as the Garden State, right? So, oh yeah, so here's my, this is my Okta.com, you know, org URL right here, right? You know, yeah. I was able to change the password. Yeah, if you don't mind, we can run this. So hopefully it'll work. So it's old, but I'm doing all kinds of fun stuff today. So
Actually, you already committed your password on GitHub.
what's that? I'm sorry.
You already committed your password on GitHub. It's so dangerous, man.
Is it? Oh, did I?
The credential was there.
Oh, was it? Oh, geez. Okay.
Yeah.
Yeah, I didn't realize. I did this as an example.
That one, token client credentials.
I don't even see it.
Yeah, 11.2, 112, line 1.
Oh, 112.
Yeah.
Oh, yeah, that's, but it's like, okay, yeah. It's encrypted, I guess, so.
I don't think so.
Right? Or that here you're saying, right?
Yeah.
Yeah, that's interesting. I forget why that is. I'd have to log into my Okta account. I did this again 3 years ago, and
You are so lucky.
yeah, so
Your Okta account is not compromised yet.
yeah, I mean, I haven't touched it since I did this, and it should. Let's see, where would I have that? Where would I have done that? Yeah, change this one. Do I have an Okta one? No. Unless I had it in my regular Java here. I see something in the chat here. Oh, okay. Oh, okay. That was Sebastian. Okay. All right. Where the heck did I put that? I know I had a local copy of it, of course, right? So, or maybe Okta apps. Let's see. No, I didn't have that there. All right. Well, I don't want to waste too much time on that. Maybe at the end, if everybody's still hanging in there on all this. But yeah, so how that refers to Helidon, I don't know. We could take a look at the documentation, of course. Oh, one of the things too, how come I didn't security? I just went right to the thing there. I didn't oh, here we are. Okay. Yeah, I didn't cover this, so let's do that and then we'll go back. So sorry, I'm jumping around here. It's security is an original Helidon component, and you have authentication and authorization, right? And even audit and outbound, and a number of different. Oh, there it is. OpenID Connect. Yes. So I think we saw the basic. There's the digest. I think we saw that. The ABAC, the attribute-based access control. I think there was one there for JWT, and there is OpenID Connect. Yes. So an IDCS role mapping. So that, yeah, we took a long-winded approach to answering that question. So, and there are 3 different ways you can implement security in Helidon applications, and there's a builder pattern where you manually provide a configuration pattern, where you provide configuration via configuration file, and we know how to do that, and then a hybrid of both. And when I wrote the tech article 2 years ago, I believe I did number 3. So we'll double check. So these are the coordinates, and again, it's the same pattern: IO, Helidon, and then whatever the name of the component is. There are some variations to that, but so you get the idea. And there was the demo thing for that. Yeah, so I guess they didn't provide it in there, and so unfortunately, so okay, Helidon, okay. All right. Oh, examples in security. Yeah, so if we go back and look, the different types you saw, attribute-based was one of them. Yeah. So digest, authentication. All right. So these are things maybe we can experiment with them a little later, or if, we can try now if you want. So it's up to you. Let's see. Let's do a new one. CD attribute. This is good stuff. So LS. All right. So idea. Yes, we can trust it.
Michael, I need to drop off for like an hour. Somebody from the office pinged me. Is that fine?
Okay. Yeah. Why don't we take another break, and this way you could take care of that, and it's been almost an hour anyway. So I wanted to mention, I mentioned yesterday I write for InfoQ, and this morning there was a big milestone with one of the editors Sergio Di Simone. He broke 1,000 news items recently, and honest to God, this guy's a machine when it comes to writing news. So our news manager acknowledged that earlier this morning, and so everybody's been congratulating him and all that. That's a lot. I got so yeah, mine is I got 200 and change, I think, and he's been doing this since 2014. So I only have 204 since 2016. So I have a bit of a way to go to catch up, but I digress. But you know, and by the way, if anybody's interested in writing for InfoQ to write news and to do things like technical articles, you know, or you know, to review articles from external speakers, we are always looking for people to do that. There is a sort of a training / audition process, and you know, so it's usually 3 or 4 news items, and it's, you know, it's there is a journalist from academia that does the initial screening too, along with the reviews I do on that. So, but yeah, it's been one of the great things that I've gotten involved in 6 years ago. So, but you know, if you want to talk to me offline, if you're interested, let me know and I can help you get going. But yeah, so you know, so I guess to continue on this, I don't know why it doesn't work.
Demo part. I think we were on demo.
Yeah, that's so, oh, but the new one, that's right, the attribute based one. So we could try that out and give that a shot here.
Yeah.
I don't think that'll need much. Hopefully it won't need anything extra, you know, like any other configuration providers. All right, so it identifies all these things. So, okay. Well, let's give it a shot. So first of all, I got to fix the POM file. All right. So then that should resolve all that. I should fix the parent ones too, but I don't. It doesn't seem to have an effect. It seems to compile and run. So attribute based. I touch this one here. Okay, and it recommends to do. Okay, so basically the standard stuff. All right, excellent. Yep. Oops, packet. Oh, geez, taking a while. It's a warning. File name based automotive auto modules detected. Okay, let's put the warnings. And, nope, need some other stuff now. Okay, excellent. All right. Oh, didn't like that.
Oh, yeah.
Linkage error.
Linkage error.
All right. 30 examples, ABAC. Oh, okay. I saw this error, I think yesterday. I was oh, why is it at 11 again? All right.
Yeah, I think the version of Java is problem.
Yeah, it wants to be at 117, but I could have sworn I had this on. Oh, you know what? This is a okay. This is a newer window. That's why.
Yeah.
Just realized that.
Every time.
What's that? There you go. All right, let's rebuild it. Now. All right, now we're talking. All right, so it has talks about some endpoints you can use here. Let's see how well this works. No, of course. Go back one. No handler. Okay, that didn't work well. Using declarative versus explicit. But is it, I say it's up and running? Yeah, that's not oh, that's not good. There's no test to even take a look at. It was complaining about something else earlier. Oh, that was yeah, that was with Java 17 versus 11 issue. So it looks like but every time I try something here, I get this output, right? All right, that's just the explicit resource. Different scopes in this case. Let's see, application YAML. Let me look at that, everybody. Yeah. Oh, there's all these other endpoints here, /user/query.
But to be honest, the Spring security framework is so straightforward than the Java IDE Railman claims and these kind of things.
Yeah. Yeah, it is definitely tricky.
Yeah.
So, well, we gave it a shot here. I don't know why it's not working. I mean, you know, obviously if we took some time,
Yes.
you know, offline, then, you know, we could probably figure it out, but all right. I'm going to close out some of these because I think everything's slow. I'm wondering if I have too many close up. Let's see, close this project, not all of them. I don't want that. Keep this one open for the time being, but we can probably close a couple others here. Let's see, status counts, metrics, messaging, GraphQL we got to look at, MongoDB, reactive. Okay, all right, let's continue then. So, all right. All right, metrics. So this is another original component, and it's of course inspired by MicroProfile metrics itself. And let's see. In this case, there's a note here. It does not fully implement the specification. And I think, yeah, that's reactive. I think that's that. Yeah. So, because, these are specifications and, there's implementations. So, or compatible implementation in that case. So, Helidon metrics, Helidon SE, I should say, as a way for, Helidon service to basically do what metrics does. In this case, export monitoring data like telemetry and all that, right? And, you can register and update metrics and expose that telemetry from all those services. So, but it's interesting why it doesn't fully implement that. And we can go back and read that for some reason. And, as per usual, our coordinates are like that. And let's see. Had a metrics demo here. I think it was HTTP status count. Okay. Yeah, that's it right there. Excuse me. In this one, we have a couple of them here. We have a filtering, an exemplar, and KPI, excuse me, an HTTP status count for SE. So I chose that one. All right. So in that case, I think I have it open already. So we have our main. And we're going to start there. They're going to, it starts the server in this particular example. There are a couple different ways of starting the server. The routing, there's the, here's a metric support class that it creates. All right, and then there's even a thing for health too, so health support. So there's the greeting service. Again, I think that actually just goes back to the original hello world, or changing that to hola and all that good stuff that we did yesterday. But here is where you can define your different service, your metric here. So it does have has a data, an array of counters to hold 6 of them, right? And you create the service, right? There's a create method, right? Returning a new instance of that, and right there. So metric registry is used quite a bit, with MicroProfile and and all that. So. And then you can define your data right here. So, with the name, status, counter name, and you probably see that in the output, right? So, and then just you register that way. All right, let's run this actually. There is even tests too. We can take a look at them. That's always easier sometimes. Start the server, stop the server. Okay, so here, very simple instances of the web server component to start and stop the server. Now, in this case, it doesn't do the await. Oh, no, it does. I'll take that back. It's right there. Yeah. So. All right, so we're testing the MicroProfile metrics, right? It's going to do the simple greet and then greet count for the test, and assert that it says hello world. And then there's also here / metrics that is, by default, but it's being explicitly defined here. And then we can test it right here. And that you get a code 200, HTTP response. Testing the health. Okay. And then here was simple greet, hello world, right? So let's run that. Let's run the test real quick. So, all right, so so you can see it passed all the tests. And I guess if we do that, we can take a look. So do it the other way. We can run the application itself. No, it should be this out. Okay, yeah, that's the, was a Greek metric. Should work, hopefully. No. That was it. Oh, did I just
Metrics.
I took the slides down.
Yeah.
Override, that's all right, I can get them
Push
back.
the back button. Yeah, I wanted to say that to warn you.
I saw it real fast. I'm like, well, maybe I'm saying things. But obviously wasn't. Oh, slash greet, yeah, that's the usual. So, well, those are that's the test though. So yeah, hold on. So there was all these others. There's the metrics that we'll look at that. Oh yeah, simple greet slash greet count. Okay, yeah, and then no, it didn't tell me anything. Supposed to probably counted it. Huh, very strange. Yeah, because you can add things like counters and timers and all these other things. Let's see, where would that be? I think I know where that would be. You can go look at wow. The contribution I did to Tommy a couple of years ago, also under examples, and should be here, I hope. Was a histogram. Now this isn't using Helidon, it's using MicroProfile, but hmm. 4 years ago. Okay. Oh wait, here it is. MP metrics histogram. Yep. So somebody fixed the palm, and okay, that's fine. Yeah, so you can see this was my contribution, right? So all right. So again, I'm using microprofiles, metrics, histogram, and everything else. It gives you a better idea. So I created this weather service, and at the time it was in the 40s and 50s, and actually there's some 20s in there, in the New York City temperatures in this array right here. So I created the, and here's using injection, CDI, right? Inject the registry. And if I remember correctly, metric registry may have changed from a class to an interface or vice versa. And I'd have to go back and look. So I think that change was made after I submitted this. Now, of course, I didn't refresh or do a fresh pull, from that. So I don't know how much this has changed, but at least we know this is good. So when it was done back then. All right. So in the metric annotation, you provide the name, a description, and a display name. Those get shown up at various places, and have a histogram endpoint. Okay, the media type is a JSON, right? And so it's a weather service. So I have a I have a get temperatures method that returns a histogram, and you start this metadata, and you can give it the type, the temperatures, which corresponds to the metric name, right? The metric type, and so it's an enumeration, most likely that there's a metric type dot counter and so on, and set the description. So, all right. And then basically, I do an update on all this. Okay, where's the update? Oh, weird. For intemp to update each temperature. And then here are the most New York City registered. So this, let me see if I can run this weather service. Yeah. But you get this gives you an idea how you can establish all that with metrics. Now, again, there at the time, it was probably before some breaking changes in metrics itself. Because I know 3.0 was had some breaking changes. They all do, right? So the histogram, where's the update method? It's amazing how much you forget when you do these things, right?
Yeah.
So, maybe it's a histogram part of it. Let me see. Hold on a second. Oh yeah, so the histogram, right? So I create an instance of histogram, so it has an update method in there. Okay, so I just basically iterated through, that. Oh, yes, it Paretoed everything into, into a histogram itself. So, yeah, so that's just another example of what you could do to do with that. Yeah, I don't know if it's worth, if anybody wants to stick around at the end, we can play around with some of these things. So I can write down, for example, Hami tribe. Right. Yeah, these. So the examples on the Helidon are, can be a little hairy, and I think you should focus on trying to come up with more simple examples. But that's why I'm going to some that I know I've already done. Could have sworn I had a Helidon security one too, so we'll take a look at that later on. So, all right. Close out some of these things too. Keep that up. Close that. Now, if I can go back and just go. There we go. You see how everything's slow? You know, a lot of times when you're on Zoom, it tends to take up a lot of resources as well. Where are we? Security, we did that. Metrics. Yeah. Yep. All right, health checks. All right, again, another original Helidon component. And just like the health that we covered with MicroProfile, does the same thing, monitors the health of your microservice, right? And basically will, you know, if it finds out that it's not up and running, or if it's not healthy for whatever reason, if there are custom health checks, then it could, you know, kill the current microservice and spin up a new one. And so, and then here's a reference to Kubernetes, that the, you know, something or an orchestrator like Kubernetes can take some action and, you know, take care of things as necessary. So, you know, these are the kinds of things that it that health checks looks for. It's network latency, storage, database, and maybe other services. And there's the Maven and Gradle coordinates. Okay, I didn't put a demo thing in there, did I? Silly me. All right. All right. No, I had one open. Oh, basics, that's right, another basics, okay. Mm-hmm. All right, so no tests in this one, you know, pretty straightforward. Okay. Okay, so in this case, in our main here, right, we have health support.builder, our method to do that. Add liveness, remember we talked about that yesterday, and then readiness. All right, example health check, that it's with the up method with data that has got time, and add that to here. A health check response that it's an example start check. We'll say the same thing. All right. Then of course we had our routing and our web server start and all that other good stuff. So, all right. The README says just do the basics, right? Yep. Pretty sure this worked out as it should. All right, so we have a couple things here. All right, so this is the usual 59244. Okay. All right, so basic hello world, and then the other one was, oh, just health itself. Right? No. All right. So, so we did, saw some of this yesterday too. Oh, here's example health check. So this is a custom entry into this JSON file here. It's the same time, it looks like that, right? Example start health check. Here it has some heap memory. Okay, that's free. I guess that's my system here, 116. I don't think that. Weird. So if we do it again, let's see if the dime's different. So it ended in 7590. Yep, so it is a different number for the time. Okay. Yep. So one was a response, if I remember correctly, in here. Yeah, there was a health check response. Oh, that's also the same. Okay, it has two of them for some reason. Let's change the name of this. Let's call it custom health check. Yeah, 59,244. See if that this is a different port number. Okay. Yeah, different port number.
Yeah, every time we got different port numbers.
Yeah, it's dynamic, I guess. And I guess that's a good thing, right?
Yeah, avoiding conflicts.
Yeah, exactly. Oh, that's weird. Oh, custom health check. There it is. Yeah, there we go. Good. So
Yeah, there's
now, just under curiosity, let me see something here. Let's try something else. Let's try something somewhat dangerous here. Oh, it doesn't have the up dot up. If there's a dot down. Yeah, it looks that way. All right, let's see what that does. Bad things could happen. As long as it doesn't blow up the laptop. At least for today. I am concerned. This laptop is 9 years old.
yeah, time to change it.
Probably, yeah. I can't even upgrade to the latest Mac OS. I'm on the second.
No, don't do that.
No. I read that you could bypass Apple's warning not to do so.
Yeah.
So, but I'm not taking that chance. Yeah. All right. All right. Oh, status is up, even though I said dot down. Oh, weird. It's 59,286. Yeah, that's the new one. Oh, maybe just I don't know I have to read up what the dot down method does. So, but now anyway, we got it going. Oh, with data, right? Okay, time. All right. And yeah, here's the hello. Yeah. So here's using the request and the response, right, to send hello world. Right then, hello microstream. Actually, I'm changing these on the. That's okay. Yeah. I'll just do a pull from my main GitHub. Yep. Hello, microservice. Okay. All right. Now, you know, that's pretty straightforward. You know, just as a reminder that there are, you know, any microprofile application, if you don't define any custom health checks, there are basic ones that will always be included, like the status, you know, being up. I thought without, I mean, I didn't check the documentation, but I thought maybe since there is an existing down method that it would actually have that status as down, but obviously it doesn't. But anyway, yeah, so that's health checks in this case. All right, so one thing I should have covered yesterday on reactive systems, I made mention to it in reactive manifesto, and I went ahead and looked, and responsive systems themselves, they had those 4 attributes, and I found a cartoon that would, you know, shows how they are all interconnected. So responsive, resilient, messaging, and it being elastic. So those are the four things. So you know, and this is an architectural style that delivers a responsive system by infusing asynchronous messaging. And basically, you know, reactive systems characteristics are resilient, obviously, you know, and become more elastic by scaling up and down the number of message consumers. So that's, you know, quite the you know, the setup about reactive systems. So it's been around for a while. I think the reactive manifesto came out, I want to say 10 years ago, but I could be wrong. So reactive messaging was introduced in Helidon 2, and it's a model for declaring context and dependency injection beans that produce, consume, and process messages. And the communication between that is using the reactive streams operators in this case. All right. So that one's straightforward. That's with the messaging right there. And we have a demo for that. Yep. Is this the one from them, I think? Or yeah, this is it. I think I found the messaging from someone else this morning. We could take a look at that as well. Yeah, it's got a web page too and all that. So I have to remind myself what it did, or how to do this. Oh yeah, that's right. It has a it runs a little application. So okay. All right. Oh yeah, I used JMS WebSocket SE. Okay. Oh. Yes. Okay. Oh, lovely. Yeah.
Oh my God, ActiveMQ. It's kind
You know, never a dull moment. I'm on 17. Did I have to downgrade to 11?
No, you are missing ActiveMQ factory.
Oh, that's right. Okay. No. It's not part of this. I think I had to have it. No. All right. Let me find the other one here. I thought I had that running with the, unless there was another app with 7001. Oh wait, JMS. Oh, I take that back. Here it is. Here it is. That was a different one. Yes. Okay. Yep, I did that. I didn't read. Let's not the jar 3.0. Oh, in the POM file. Let's see if web socket. Must be in here. Oh, this had a problem too. Good Lord. Unless it just needs to be refreshed. It says it's synced. No. Let's just go with this anyway. Wait, didn't I just try this? Yeah, WebSocket. No. All right. I'm running into all kinds of trouble today. All right. Well, this was the one from somebody else, I think, right? Helidon examples, microprofile. Yeah, it was from someone else, didn't I? Oh, I didn't try that one. Yeah, okay. I didn't run that one. All right. Helidon messaging example. That's what we want. Okay. Yeah, this one I think had a nice little user interface. You know. Let's see. Helidon messaging example. Helidon example. Okay. This is probably old. Hold on a second. So,
Yeah.
that's no source. This one I just did a search on Google and I came up with that repository. So yeah, see, there's localhost 7001. There we go. All right. So it has this stuff in here that you can send messages from this side and it puts them over here. So fly, Helidon, fly. There we go. And it does a lot of, yeah, it does a lot of changes on here. We'll look at the source code in that in a minute. And it even puts in some, you know, some default text you can put in there. Oh, I hit the send button. There we go. So it actually, what it does, it changes, it changes the text accordingly. So it looks like it does it all backwards. On this one here, that kind of puts it all in uppercase, and all kinds of other things. We can look at that in a minute. So this is kind of fun, So I think this one demonstrates what messaging is all about, right? Because you go from one microservice, to another, and that's the whole point, right? So there's one here. Yeah, I thought this was part of the Helidon examples. I know I left it open, and all right. If you try to, let's see, if you try to run this, it doesn't seem to work by, if you try to do the MVN exec dash, all that good stuff, this doesn't seem to work. We can try it again, but a lot of the stuff is happening here. There's a processing bean, and all right. So here is a process builder. So here it's a 2 uppercase and a repeat. So it's a multiply method, right? Return a builder flat map, right? And then puts together a string builder and then reverses it. And that, in this case, prepare publisher. Okay. Create SEE broadcast SSE broadcaster. Okay. So let's see. So we can look at emitting publisher. It's a fail. So this complete doesn't seem to be seems to be unused since it's grayed out like that. Yeah. Oh yeah, but there was a call to emit. So I think this emitting, if I remember correctly, going back to that marble diagram that we saw yesterday on reactive streams operators, was putting out and processing data. So I think I showed the example of 3156 where it just you can create an empty reactive stream. You can add, you can process stuff that's in the stream. So that's the kind of thing that's going on here. Okay. So listen to events, get sent. So these are things that process that trigger all these things here, right? So, and I think this is the main application. Yeah. So we did that already. So, yeah. So this one's fun and works. So, it's in our. Oh, okay. Yeah, the port number and the web. Yeah. So in this case, it has a web folder. And you can, guide this to, where your index HTML file is and everything else. So yeah. So this probably, corresponds to all the different methods to, to trigger when you send something and all that. All right. All right, reactive stream. No, reactive streams operators. Again, also Helidon 2.0, and this one does implement a microprofile specification, corresponding reactive streams operator specification, which is, if you recall, that was one of the standalone specifications in microprofile. And so, this is, a specification for, manipulating reactive streams, and you have operators you can do to, to apply a map, a filter, flat map, or, those kinds of things. And you do them as you saw the same way as you do the stream API in Java 8 that was first introduced. And so this one's a little bit longer. It's, so it uses, you can see it uses microprofile in the namespace here. Instead of just io.helidon reactive streams, it has microprofile in it. So, and let's see, what do we have here? I think we had the reactive streams. Messaging, reactive, I think that was it. Oh, this was one of my own that I happened to find. I don't think I found it yesterday. Well, the test itself is just, yeah, nothing exciting. So the main here is where you create a stream of numbers, right? And oh, that was 2 uppercase if you had a string. Okay, filter anything greater than 4, so it should put out 5 and 6, and then to to print line and to run. So we can play with this one for a few minutes. We'll put in some text and we'll adapt this as accordingly. So, and this one is in small rye apps. Small rye is an implementation of microprofile specification. So small rye.io, if you want to learn more about that, so they had, I thought they had some applications, but I think it had some difficulty with them too. So here are all the projects. So yeah, so you can do some of these as well. So you can see all the microprofile specs. So context propagation, reactive messaging. I may have tried that one. Standalone. Well, let's see, open telemetry. So look, it's already got open telemetry in there. So this is something to evaluate if you like at some point. Okay. All right. So what I did here was yeah. Oh, we can just run it here. So okay. Oh, it says hello world. Wait a second. Am I got the right one here? Reactive. Oh, wait, there's 2. There are 2. Yes, main is the one. Yeah. Oh yeah, 5 and 6. Yeah. You should try to separate that out so it's a little bit easier to see. So yeah, 5 and 6. According to what we did here for, we filtered here, but if we do here, let's say, right. All right, who wants to be in here? Put Amir. Oh, Amir. Yeah.
Thank you.
Okay. All right, so we can put these to uppercase. Now, of course, we got to change our filter to something that,
contains A, for example.
yeah, let's see. I forget how you do it. Just do it like that, right?
I think you cannot use a greater
like contain. Yeah. Well, we can instead of messing around with that, we could just take that out for now. All right, and then for each, well, not really a number, but that's
Yeah, it's okay.
just a variable name.
Yeah.
All right. Okay. Yep, and then you see all the names have been converted to uppercase. So
Yeah.
Pretty straightforward. Why don't we do another break? We can only have a couple more left. I think I want to play around a little bit more with the database. So welcome back. All right, GraphQL. It is a interesting framework that I started to learn about a year or so ago, and probably even wrote a news piece on it. So the GraphQL in Helidon was introduced in version 2.2, which is going back, I think, about a year or two, if that. And this is, well, it's designed to be part of the Helidon web server component. And the basis behind GraphQL is to prevent overfetching or underfetching data. So, this is, to some degree, it's kind of like a in competition with REST, right? So, a lot of what you see in microservices is REST-based. You create your endpoints, for, whatever purpose you need. And in this case, sometimes, when you have an endpoint, you can potentially get too much data, or where you have to, if you need more, you have to call it again, or you don't get enough. GraphQL is designed to eliminate that, right? So, and it says here too, an alternative to other, to gRPC as well, so remote procedure calls. So that's the idea behind that, and it's kind of an interesting thing. So it has its own, Maven and Gradle coordinates. We'll try to have some fun with that. Let's see. Let's see. GraphQL basics. There we go. So. Okay, yeah. See what. Let's run this. Let's see what this says here. Tests. Oh yeah, this was a little bit different. I know they make UIs for that. Maybe we can find one as well. So, all right, but let's just play with this then. Let's go back to here. Oh yeah, CD basics. Okay. Okay. Localhost. Yeah, if I remember right, this, let's see what that's with. Oh, a query must be defined, right? Right, that's what it was. Oh, it didn't. Of course, it didn't like that. All right. See what that does. I didn't try this earlier. So. Oh, okay. Here's something. You got something here. Oh, and I saw this defined in the code. The query itself, you know, is a key value pair here, right? So take a look. Web server. Oh yeah, so there you go right here. This is so this is the build of the schema itself, and you can just call that micro scheme instead of just a. There we go. Yep, capital S. But it's in the fetchers right. Here's a data fetcher. All right. I know there was a UI. You can try to find that. Yeah. There was also something in the README about using curl commands here. So about the queries. Oh, the port number. Yeah. Let's see. $60899. There we go. Okay. So you can do it that way. So yeah. Oh, field is missing. Oh, interesting. Oh, it's not defined. Interesting. Yeah, yeah. So go to the GraphQL thing itself. Let's try that out. No queries and mutations. It's code. I thought there was a let's see. Drag and drop GUI builder. I don't know if that's oh, you gotta have to, yeah, here, I remember what that was. Clients. Oh, here we go. So here's an example, some examples of using this with JSON. Okay, hold on a second. It's could be it. Only one instance. Yeah. So I wrote this over 2 years ago. Let me see if there was a. Oh, here it is. Ah, okay. Example REST and GraphQL applications. So this is what I wanted to show. You know, the way you could, you know, the way you could do that, do some conversion. Query strings on the left pane, and then the resulting response in the out, you know, the other pane. Hey, hey, look at this. All right. Say hello to everybody. All right. That's one of my 4 cats.
Oh, nice.
I didn't think she was going to jump up. She doesn't do that often down here. So, let's see. All right. So this was with Quarkus. All right. Oh, by Philip Kruger. Yeah. Okay. Oh, there was a. I saw that on my. Hold on a second. Yes, all right, there it is. Yeah, that was about right. Same time. Yeah, okay. All right. Okay. All right. I probably didn't have it. Oh, there we go. Okay, good. Let's package it. Okay. No. Oh. Okay, got draw. Okay. Yes. Oh, no manifest. All right. So that didn't work out too well. It's been a couple of years, I guess, since I did that.
Yeah.
Yeah. All right. No, you don't want to waste too much time here.
I think there should be something in README file mentioning the
Yeah,
main class.
Yeah, let's look at that. You're right. That's a good point. Okay. Yeah. No, it doesn't say endpoint. No, that didn't tell me much, did it? That's the image, right? Okay, that's all the images there. No, since I didn't create a IntelliJ idea project for it yet. Let's see. Oh, that's weird. Okay, nothing in there.
Yeah, something in dependencies.
Yeah, so there's no source code. So
Yeah.
what wasn't in there? That was a waste. Let's see. All right, we had here common server tools. Going back just over 2 years, right? API implementation. I'm not sure if that's going to do anything. Oops. Netflix. Yeah. I think we were already here, right? Yeah, code. That one. I thought they had learn. I thought they had a built-in client where you can do it right in the website. Yeah. All right. So I guess the main takeaway here. So you create these queries. All right. That looks like, that looks like JSON, but it isn't. But and the response is in JSON. So it's a matter of formatting. Exactly what you want from your data. So, yeah, could have sworn they had one over here. So you can serve over HTTP. Okay. All right. Yeah, get request. Okay. Can do a post if you wanted in this case. Yeah. So. Yeah, like I said, maybe they updated this and they took it out, and yeah, it's unfortunate. So we looked at code already, right? Yeah, language support. Yeah. Okay. Anything more on learn? Yeah. So anyway, this the Helidon version is there for you as well. So that's that. Thanks for hanging in there with me with all this. Sort of go perusing and having
No
some
problem.
So so, yeah. All right. I think the last thing I want to do is the DB client, and and this was also introduced in version 2. All right. This is a way of having a reactive API to work with databases in a non-blocking way. All right. That kind of thing. So we can use these for both relational and non-relational databases. So think of MongoDB. There are your coordinates. Oh, and they have coordinates specific for JDBC and for MongoDB. Right here. I know we saw some of this yesterday too. So I downloaded again the database.zip, right? Yeah. So right before we, well, after we got started. So let's play with that. We'll try to put this in a Helidon app. Let's see. So let's do this again. Oops. Okay. Do any of you guys use ZSH for your terminal window?
Oh, my Z shell. I'm using my Z shell. Yeah.
Oh my, yeah, yeah, I love it.
Yeah, I like it.
It'd be nice to have 4 going back up more, but it doesn't allow.
Yeah.
3 dots is the most, right? So, yeah. Oh, what did I just do?
The most important thing is to showing you the Git branch.
Oh, yes, that's right.
Yeah.
Yes. I know that's great for for contributions. When you create a new branch to contribute, then it explicitly says what they are. Yes. Yeah.
Yeah.
So, let's just go. There we go. Okay. Not there. Okay. Okay. Oh, database SE, that was yesterday. Oh, okay. And maybe I'll overwrite it. Now, we can actually use that one, can't we? just used it yesterday, right? It says, yeah, what, 9 o'clock in the morning we did that. So, okay, let's open that up and instead of going through the whole rigmarole. Let's close all projects. Take a few seconds. Maybe. All right. The database, I see. I think you're taking it out. Okay. That's all right. Open. Okay. There we go. Nice. I left everything open from yesterday too. Okay. Good. So this was from yesterday, and it had. I thought it was Oh, you know what? Maybe it wasn't MongoDB. Then I didn't have to do that anymore. I think we use the built-in, right? Yeah. All right, we'll have to fix that. Yeah, because I should have opened Compass before, but anybody use MongoDB here?
No, unfortunately.
No. Yeah, I still have MySQL too, and but I got into MongoDB. I don't know, about 2014 timeframe. Sort of got into it, even though I know that doing queries is a complete nightmare in terms of all your parentheses and everything else, and colons and the whole thing. So I have a few things. I know when I was playing with this last week, I think there was a Pokemon. There we go, Pokemon. Yeah. So yeah. So yeah, I did play around with this last time. So but yeah, I wanted to do the MongoDB version. I don't think this one has it over here. I think this is yeah, the H2. So we will have to yeah, okay. That's fine. Give me 1 second. All right. So let's see. Zip dot. Okay. Oh, just a database. Okay, that's fine. So. Okay. Yes, we will test it. All right. So this should be a little bit more to what we need. Okay, so yeah, so you can actually run if you don't have MongoDB, you can actually run Docker to have that in there. It's all packaged in there. So this is the same as yesterday in terms of what I looked up here. Based on some of the method names, they reference DML, and I had to remind myself what that was, and is data manipulation language. So I assume I'm not going to say this as gospel, but I guess this is all part of that, because there were a lot of methods in there that had the word DML in it, initialized the database right here, and this is where it it wired up to those SQL statements. if you remember right here, name the DML right here as a method, and create Pokemons, which then creates right here, create table Pokemon, right? All that good stuff. So it'll probably overwrite, this Pokemon database. If I don't know how much of a pain it would be to convert this to something else, like, instead of Pokemons, it's coffee or beer or something like this, right? But that could be something, homework for the user, right? Because there's been times I've tried to, adapt certain things, and it's just a complete nightmare. So, but anyway, yeah. But yeah, so that's what we have in this case. So you had the H2, the in-memory database, and then now this is MongoDB, and I forget what the other ones are. I think when you just counter anymore. Take a look at what the other options were here. All right, so if you do database, and then we do, oh yeah, so you have MySQL, Oracle DB, and MongoDB. So that's that. So yeah, so it would be nice to actually connect to existing databases. Of course, you'd have to manipulate all that to point to whatever you have here. So we have this existing one. So let's just work with that one. And you saw in here you have the 12 Pokemons, right? This is what's nice about this UI. You do have a Mongo. Let's see. So MongoD is the daemon to start this, and then you use Mongo. We'll use it down here. I think it's in my path. Oh yeah. What's that all about?
Command line.
Oh, okay. This is okay. So show databases. You can have the different databases here, so you can use whichever one. I have a Microsoft one. Here's Pokemon. It's Pokemon. Okay, switched over to there. Show collections. So one of the things about MongoDB, it's a document database. So instead of a row, it is a collection. All right. So then db.pokemon.find gives you all of the Pokemons in that Pokemon type collection. And then you can actually, if you wanted, you can do this, which is just a cute little thing here. So you can actually have it formatted that way. The only thing about this is when you do queries, it's it's a nightmare to ensure you get things right. I've tried my hand at doing some kind of inner join, even though it's not technically an inner join. And I tried to do it programmatically with Python in a project to have it work, and it just the programmatically part didn't work. So but you can do it on the command line. So I had different collections, and I had references in one of them to point to the other, and that kind of thing. So, but yeah, so MongoDB is definitely become a popular document database among some of the others. And of course, you have your other NoSQL types of graph types, key value, and there's one more I'm thinking I can't. Yeah, I know there's 4, but in any event, yeah. So that's just a little side note on that. So, but this is a nice interface too. It's called Compass. So if you're ever into MongoDB, you can use it. I'm sure I need to upgrade. This is version 4, and I forget where they are right now. So yeah. So in our main class, and we kind of looked at this yesterday, right? We're supposed to start the server, do our config, and we have our application YAML file, and port 8080. So in the database here, our source is MongoDB, and I would presume that my SQL and Oracle DB would be very similar. And then this is a standard port for MongoDB. It's 27017. How they came up with that, I don't know. They didn't ask me when they created it. So, but yeah, I find this interesting. And you notice here, they use the word collection, in that, right? And then the query. Oh yeah, so here is a query. This is standard way of referencing things, and so while we're at it, I want to show you. I think it's portfolio. I do have an old MongoDB talk. There we go. Yeah, slide deck. And I just want to give you an idea of some of the querying while we're on the topic here. Yeah, so what a document is, so this schema list, that's the other thing. What I like about being schemaless is that you can, so in this example here, you have a JSON file, right? And so, but if there's another entry with somebody else's name in here and you don't have their email, you don't have to put a null, because it's a, because of a relational database, you have a fixed schema, and so if there's no value for it, well, you have to have email and then null is a value. Well, document database, they don't care. So your next entry, your next JSON entry could be last name, first name, and then roles without the email. So that's one of the reasons why I chose MongoDB for a project at work, where you can put in, it's a list of polymers, since I do a lot of polymer physics type of work with measurements and all that. And then, it's, okay, does this polymer have various characterization? Does it have, rheology data? Does it have NMR? Does it have, GC or any of those things? And you can actually capture that, and you don't have to have a bunch of null fields with that. It is what it is. So that's the beauty of that. And so I wanted to show, okay, create a collection. I just wanted to do the queries. Read, here we go. All right, so what I did in this presentation is to compare the way you would do this in MySQL versus MongoDB. So you see the difference there. Standard SQL statement versus db.collection, the collection name that you saw me execute before. And here you can, instead of a standard find to get all the results, right, retrieve all the documents, and here you can specify similarly to MySQL. So you can, instead of collecting the two columns, the way you do that is this sort of this empty set of braces, field 1 true, field 2 true, and this assumes, of course, that there's more than 2 fields, and so you would get that data from that. So you can see where this already gets a bit complex, right? You could do a select star from table where some column equals a value, so that's kind of cool. And then you saw the representation of that in ID, and it said ID colon, right? That kind of thing. Here's a way to sort. Okay. Oh, you can do a find one. There's a find one operation in MongoDB just to return a single document. Then you have various selectors. Okay. retrieve specific rows. Oh yeah, where column does not equal value, so field, whatever that happens to be, and then see. So you see all the curly braces. It gets a bit complex here. So that just gives you an idea what to do. I think I don't know if I did joins. There's an aggregate function in MongoDB to get that is some form of an inner join, or to get values of, in this case, this was an officer whose tenure is from, you can see the date here, 2014. So this is a bit old, and you can get that, aggregate that data. So, but anyway, but yeah, so that's the whole idea behind MongoDB. But so now I heard that, like Twitter, and this is a while ago, they'll use a NoSQL database for real-time processing, but then when they back up, they back it up to a regular, like a MySQL relational database. That's kind of interesting. How true that is, I don't know, but so where were we? We were here. Okay. Yeah. So select Pokemon by name. Oh, so in this case, you see the difference where you're using that what I just showed you in that presentation to do various selects. So in the other project, the H2, it used SQL statements. So that's the deal there. So again, I think this is a POJO. And if there's no reason to use, Java 16 or records from Java 16 and beyond, and so like we did a lot of this yesterday, right? So why is that dot Helidon? Yeah. All right, so we don't need to run the Docker unless you don't have MongoDB, but you can do it that way, right? And so, yeah. And the test pass, that's very nice. Oops. You sometimes forget that you can't code complete with the oh, here it is. No, it's not. Oh, database, I draw. All right. Yep, so there's the URL. All right. Yeah, so yeah, it does just puts everything out. Should be a way to do other things with it, right? Oh, you can do that. That's a simple Greek. Okay. I'd like to be able to add a Pokemon. And you notice here too. So yeah, this is using the file name. I thought there were more endpoints here, but we can take a look at that in a minute. Oh, like there's all of them. Maybe by ID. Oh, by type. That's right. Localhost Pokemon. Hold on a second. Let's try that. Yep. Oops. Yeah, okay, so here's the types themselves, okay. I don't know if they define endpoints to add one or not, and that would be nice, because I thought the should be able to add, right? Select, insert, here's an insert. Insert records, insert Pokemon. Okay. So I see a lot of the JSON I just showed you in you know how to do that. These are obviously parameters, you know, holders. The test had nothing to do with the database. Okay. All right. Well, so much for that. Yeah, that's weird. Maybe this is where you can add a new one, I guess. Okay, let's try that. Okay. Put something that we know, DB type 1, tests, micro stream.
I think you are in the command of Mongo.
Oh, yeah.
Yeah, you should
Thank you.
press Control D or Control C. Yeah.
Yeah. I think it's EXID.
You're yeah.
Oh.
Exactly.
Inserted value 1, so it didn't really oh, I put in test. So let's refresh that. That's type interpreter Pokemon. Yep, there it is. So ID was number 100. Yeah, so I did that intentionally to make sure there's nothing clashing there, and then we can do the same thing. So this is the way you can add in here. They didn't have an endpoint to do that, but that's fine. Put 3 and then micro stream. What am I doing? You know, all these things I start with micro, right? Micro stream, micro what? Microsoft, MicroProfile. So, oh, we got to do a different ID. (101). Yep, there it is. Okay, so yeah, I mean, pretty straightforward. You know, and you can do similar things. It's nice that this starter did, you know, provided the different ways of querying that particular database. I bet you if we did the MySQL one, we'd probably have the SQL statements, you know, similar. So, you know, one of the questions I will ask at some point, are they going to provide support for other databases? You know, so I think Neo4j is a graph database, if I'm not mistaken, and you know, there's the others, Cassandra, and you know, those are pretty popular. And but yeah, so yeah, let me so anyway, that's pretty much all I had for today. I don't know if anybody wanted to take a look. I mean, summary, I didn't really get to write much on that, and but I do, before if we do decide to play around with stuff, I did not provide any acknowledgements yesterday, and so I really have to thank Sebastian and Marcus, you know, from MicroStream. I've been working with them on a number of things for the past, I'd say at least a year. And, you know, I think first and foremost, though, I really need to acknowledge my wife. And, you know, she has been very supportive in all of my extracurricular activities, you know, my writing for InfoQ, and, you know, so, you know, the fact that, I got, started these at 5 a.m. our time, and, she had to go to work and the whole thing. So I really can't thank her enough and for her support and all that. So I definitely needed to say that. So, but so, yeah, but, so, and then there is the JCon Online coming up in September, JCon 1. I should have put that in the slides. So yeah, September 20th through 23rd. If you're part of a Java group, I believe there's a discount, or, so I am speaking there. It's probably 50 Michaels in there. I am. Yeah, so I will be talking about Jakarta NoSQL and MongoDB, and I've been delivering that one for a while. I know we had a bump in version for the beta from 3 to 4 more recently, so I need to test out my application to ensure that that still works. So next to me is Otavio Santana there. He's actually the lead of NoSQL specification, and he's also one of the leads in the Jakarta data that is, that we just started working on. So, Dmitry Alexandrov is part of Oracle. He's, part of the whole Helidon release. Maybe some of you heard it earlier as you were checking in. Dmitry Kornilov, Dmitry Alexandrov, and a third co-author are writing a book, Helidon in Action. And let's see, and Shul just came back in, and he so that it's by Manning Publications, and it's in their early access program. And what's kind of interesting about that is, though, that I was approached by A-Press to write a book on Helidon earlier this year, and I think I have 2 chapters submitted so far. So I did correspond with Dmitry and talk about the fact that we're both doing this at the same time. So Dmitry was very supportive, and I appreciate that as well. So that's what's going on. So yeah, it's be good to be part of this program. I can put in a shameless plug for our Java group next week, 6:30 Eastern time. I know that's late for you guys, but we do record these, and we have Andres Almaray talking about JReleaser, a hands-on workshop, and when we have Nikolai Parlov coming up in October. So he's going to talk about the 4 Java projects, Amber, Loom, Panama, and Valhalla. In November, we plan on having some lightning talks, and we have to figure out December still. But, this is, we've rebranded in October 2020, but I have all my meetings since 2001, when we got started at just a wee small small group. And so it's been a labor of love these past 20 some odd years. So, what started out with just myself and a couple others giving presentations. Now we have our directors. I don't know if you know any of these folks, and then
Adam Bean. So there is a guy called Adam Bean.
Oh, yes. I know who that is. Yes.
I love that guy for that videos that he does on YouTube.
Yes.
Right? He has 100 hacks on J2EE, right? And he'll give you awesome answers, man. I mean, his sense of humor is also sort of.
Yeah, he's I like how he has his top of his head on the one corner, and the background is his terminal window, and and he's just he's really cool. Yeah, I've referenced him a number of times. So yeah, and then we have leaders that help us out, do a number of things, and we are a nonprofit, and you know, perhaps you guys know Pratik Patel, you know, from the AJUG and Vincent Mayers. So AJUG, the Atlanta group, was instrumental in helping us get going as you know, part of our rebrand and all that. So, but yeah, we have a great group. It's you know, you know, we've expanded. We've gotten more you know, awareness out there, more exposure than we had previously with the you know, under the old computer club where I once belonged. But anyway, so that's enough of that. I don't know. It's coming up on. It's after 10. I know. I don't know if you know. I probably have to mess around with my histogram thing in order to get that right. So I do have stuff on GitHub if you want to play around with that. What else? Oops, I didn't want to do that.
Michael, can we get your email if I have
Oh,
questions?
yes. Oh, thank you. Yes, I meant to do that. Let's see. It's, you know, I can share these slides. I'm sure I can. I'll double check with Sebastian if I can do that. But it's yes, and please reach out to me via email. I meant to do that. My contact info. Okay. Come on. No. All right. Yeah, so email is all right. There we go.
Redlich.
That's that, my email. And then my Twitter is @MP If you don't mind, I'm trying to back off on some of the political stuff that I vent out there. So but yeah, so if you don't mind a bunch of my timeline, a bunch of cat related things, or you know, but it's a lot of software too. So so my LinkedIn. I have it on my let's see, I think it's yeah, I'm more than happy to have folks on LinkedIn to connect with them. I have it here somewhere. There we go. And that should work. Double check. Let's get the test. Yep, there it goes. Okay, we got to change that picture too. But although it's kind of a cool picture, somebody took it. We were at a company event and it just happened to get that. But yeah, so that's my LinkedIn, and that's pretty much it. You know, for those things here. So yeah, you know, really thank you very much for spending these last 2 days with me. You know, I know this was the first time we're doing this, and you know, so the intent, as I mentioned earlier today, is to improve on this, to you know, make this a better you know, make this a better you know, training course for everybody. So but yeah.
Thank you very much, Michael.
Well, thank you, and you know, please reach out to me.
Your efforts.
What's that?
Yeah, I appreciate it. Your efforts.
Oh, yeah. So
and your time.
yeah, this is going to be repeated next week for the United States. I think it's at 12 noon Eastern, and so we'll do this again next week. But in the meantime, I still have some other work to get done, which so for InfoQ and everything else. So it's never a dull moment around here. So.
Yeah.
So.
Thank you for your time, Michael.
Okay, thank you for your time. Really appreciate your attendance. So, all right,
Yeah,
take care.
Thank you. Bye.
Bye.